few regards to Professor Misro. We'll
So,
begin.
Professor Misro, what is the time there in Nigeria?
It is 9:30.
Morning.
Morning. Okay.
Yes, yes.
Okay. So it is now around 2 o'clock here, 2:05 in the afternoon.
I know. Yes, sir, I know it. Okay, it's okay. Thank you.
So let me introduce Professor Dr. Sanjay Misro, as I have received from the office. He is a professor. If I make any mistake, you just correct me. Professor
okay,
of Computer Software Engineering, Covenant University in Nigeria. His early education is in India with his PhD from University of Alcalá, Madrid, Spain, in Information Software Engineering. He has received a number of awards, gallantry awards like this, awards, patents, and he has a number of publications, handled important projects, and he has patents as well. And also he has guided, as far as I know, about 6 to 7 PhD theses, I think more now, more in the queue right now. So I request Professor Dr. Misto to deliver his address.
Okay, sir. Thank you for the introduction. I'm really happy to be in the midst of this great researchers of the India. Let me first share the screen and then it is. Yes, thank you, sir. I think screen is shared now, right?
Yes, sir.
Mm-hmm.
Yes, sir, it has been shared. We can see it.
So, so thank you so much for the invitation. Today we are going to discuss, in fact, when yesterday I was checking, it was on IoT and something for the intelligent system. So the lecture which is most appropriate for this one is with the IoT and sustainability and all those emerging technologies and how we can deal with the sustainability. Sustainability is SDG, Sustainability Development Goal is one of our target in my research center, that we are trying to achieve a lot of things in 17 SDG goals. So again is a small introduction. Who am I? It is, you can see that I have 2 PhDs. In fact, one is in applied and one is in engineering. In Scopus, you can find around 500 papers. I also chaired a lot of departments. At present, in the university where I am, it is in top 10 in Africa. In fact, number 1 is in West Africa by Times Higher Education in 2019. So one of my expertise is also to increase the ranking of the university. So you can see a summary, a lot of edited books. Now it is already increased. I think with the Springer, we have around 70 books in the Springer, several from IGI and others. Also the students, 8 PhDs and around 13 or 14 masters, several projects, teaching around software, hardware and computer science courses, more than 100 keynote speeches and invited talks around the world, and traveled around 70 countries, something like that. So this is the outline of my lecture. Abstract introduction of IoT, IoE, edge and fog computing. Then we will see that what will be the effect of 5G on the health if the time permits. And then we will go for the emerging technologies and sustainability. And then finally, we are going to the conclusion. So more emphasis will be on the 5G, because 5G is at this time in developing countries, this is a hot topic of discussion, especially in Africa, in India and other developing countries, although it has been achieved a lot in developed countries. So implementing the 5G can change our lives, everybody know, dramatically, because it connects every smart devices with super fast speed. So why it is? Because it is 10 times faster than present LTE networks. The higher speed affects IoT devices to communicate and share the data faster than ever. 5G and connectivity with the IoT devices, because our emphasis is also on the IoT devices. So today we will also understand with all those basic differences between different type of the IoT devices. It is expected that we can achieve long-term environmental sustainability towards establishing a green environment It is because the antennas of the 5G require less power and creating the protocols better for connecting a small battery powered Internet of Things devices. So this is one more thing, that it is the battery powered Internet of the Things devices. This is in addition. So in this present work, we are evaluating how emerging technologies are affecting the society and what will be the effect of these technologies for sustainability. In particular, we will show that what are the means differences between IoT, fog, edge computing, and 5G as well, and what is their need as well. So how these advanced technologies works together, how these technologies are impacting for long-term sustainability. Starting with the Internet of Things, we all knows what is the Internet of Things. This is the network of the physical objects. This means things that we are embedded with the sensors, software, and other technologies for purpose of connecting and exchanging the data with other devices and systems over the internet. And Internet of Things devices are increasingly rapidly in the world. It is expected that 75 billion of the IoT devices to be active by 2025. So you can see this is statics. So this is a picture of the Internet of Things. This is sensing, analytics, visualizations, tools. So you can see it is in the home, in the transportation, in the community, in the national level as well, in the industrialist as well, policymaker, home, personal use, doctors, cares. Well, this is up to a level. These things are available in some developed countries, but still it is not fully implemented in the developing countries. So Internet of Everything. Now we discussed, all of us, we know Internet of Things. When we talk about the Internet of Everything, then the Cisco defines it as a networks connection of the people, process, and data. I will show you what is the basic difference: people, process, and data, and things. The benefit of IoT is derived from the compound impact of connecting the people, process, data, and things. So it is not only the things, but we are also adding the people. And the value this increase the connectedness creates everything comes online. So you can see a better understanding of what is between the difference between the machine to machine, Internet of Things, and Internet of Everything. So in machine to machine, what is the M2M? These are the devices that captures an event, transmits it over a networks to an application that translates it into a meaningful information. Then in IoT, Internet of Things, this is not only the machine to machine, but this is the network of uniquely identifiable things that communicate without human interaction using the IP connectivity. And when we are going for the Internet of Everything, including the people inside the IoT, it will gives you the Internet of Everything, means people, process, data, and things to make network connections more relevant by the turning information into the actions. So this pictures gives you the clear discrimination between when we were in the past, it was the machine to machine. Then later on means from the internet, maybe from the server, it is coming to your laptop or different type of machines. Then we comes for the Internet of Things. Then we comes for the Internet of Everything. So Internet of Everything, this is the Internet of Everything, means people, process, and data. So you can see that how this picture is in more clear way. You can see that the real value of the Internet of Things lies in the value of connections amongst people, process, data, and things, not simply in the sheer numbers of things that are connected. For example, your car is coming, it is connecting to your home, it is connecting to all those devices. So a lot of numerous, valuable, relevant connections with other cars, stop signs, your homes, even the road itself will make you drive experience safer, more fun, informed, and even more efficient. This is a picture. This is what is happening now. It is the connections that matters the most. So we are going towards this direction. You can also see that how these $14.5 trillion values are the stake at this time. The Internet of Everything brings together people, process, data, and things to make network connections more relevant. So you can again see in the people, process, and data, and the things in the middle slide. People to people. This is a people to machine, machine to machine, machine to the data, data to the machine, and machine to the value and actions. So when everything is going to be connected and vice versa to all those all those devices, then it is giving you a better picture of the Internet of Everything. So value of the stake driver in the connections of the everythings is the people who connect the people in more relevant, valuable ways, processes this right information to right persons for the machine at right time. Things, physical devices and objects connect to the internet and each others, and data, from data to the useful actionable information and decision action. So you can see that this is the IOE value at stakes in the 5 drivers. This is the innovative and time to the market, customer experience, supply chain, and logistics, and employees, the productivity, asset utilization, all these things. You can see a better view of the Internet of Things. So what's the bit means if we compare between the Internet of Things and Internet of Everything, you can see that in the Internet of Things, this is the networks of the physical devices and items embedded with that electronics to enable connectivity to exchange the data. And on the right hand side, this is the Internet of Everything, which is the border concept, then Internet of Things, which defines as an intelligent connection of people, process, data, and things. For the Internet of Things, is the communication occurs between machine to machine. In Internet of Everything, this is the people to machine to machine, and machine people to people. Again, in the Internet of Everything is less complex than, of course, with the IoE, and Internet of Everything is more complex and advanced than IoT. So the basic problem, the only problem is a massive influx of the data being connected from each devices. How and where can such vast amount of data be processed? Edge computing and fog computing are two potential solutions, but what are these two technologies and what are the differences between the two? We have asked industry expert. In fact, it is already taken from the literature, but you can see that to solve the problems of the massive data, we entered from Internet of Things to Internet of Everything, and the concept of the edge and fog computing added the values to the cloud computing. Edge computing usually occurs directly on the devices to which the sensors are attached, or a gateway's devices that is physically close to the sensor. So fog computing moves to the edge computing activities to the processors that are connected to the LAN or into the LAN hardware itself, so they may be physically more distance from the sensors and actuators. And if you see that, so with the fog computing, the data is processed within a fog node or IoT gateways, which is situated within the LAN. As for the edge computing, the data is processed on the device or the sensor itself without being transferred anywhere. So in the edge computing, we are doing in the system without in the device. In the fog computing, it is going to the LAN for processing. One major benefits to the edge computing is that the data is not transferred and is more secure. Edge computing maintains all the data and processing on the device that initially created it. This keeps the data discrete and contained within the source of the truth and originating the device. So keep costs low. Edge computing technology saves the time and resources in the maintenance of operation by collecting and analyzing the data in real time. Networks on the edge provide near real-time analytics that helps to optimize performance and increase uptime. So what are the drawbacks for the edge and fog computing? These companies are struggling to understand the balance between the bringing the data to the cloud versus the processing it at the edge. In fact, to work on the edge is easier, cost effective, but taking it to the LAN is going to increase the cost. Why there is a need to take it on the fog computing or the LAN? Because not everything can be done into the device. Maybe a lot of resources are required to maybe for the analysis of the data. So in terms of the cost, sometimes it is more effective to analyze the data locally. However, in some sense, the data may need to go to the cloud, that is going for the fog computing. It can become a complex issue for the brands to handle, as the data sets that require more sophisticated algorithms are better handled in the cloud, whereas simpler analytical processes are best kept at the edge. So now the entry of the 5G. So once we understand IoT, IoE, and then edge and fog computing, there is the entry of the fifth generation of the telecommunication system. Fifth generation stand for the fifth generation mobile technology. In fact, we have seen a lot in 1G, 2G, 3G, 4G, and this is a generation of the networks. Enables a new kind of networks that is designed to connect virtually everyone, everything together, including machine, objects, and devices. This means it is directly connected to Internet of everything. So fifth generation wireless is designed to do a variety of things that can transfer our life. Of course, it is going to boom. It is really, we are experiencing a lot of changes if we are going to implement it fully in our environment. Engineered to greatly increase the speed, giving us faster download speed, low latency, and more capacity and connectivity for billions of the devices, especially in the area of the virtual reality, the IoT, and artificial intelligence. 5G will enable a sharp increase in amount of the data transmitted over wireless systems due to the more available bandwidth and advanced antenna technology. So these are the companies who has the ownership of the 5Gs. When computing granted 5G patents family only again, Samsung owns the largest 5G portfolio, followed by the LG, Nokia, and Huawei. The Chinese companies ZTE 7.4%, Chinese Academy of Telecommunication Technology cut 11.7%. Oppo is also 9.5% and Vivo is 0% at present, have very low grant rate as the number 2019. Sorry, I have not updated, I have not searched about it. What is the situation is 2020. There are also 6G. Do not be confused. This is not the generation 7G. Norway internet speed 52.6 Mbps up to the 10G. That is the NASA 91 Gbps. It means 13,000 times faster than our internet speed. So don't be confused this 6G, 7G, and 10G, because this is not showing the generation, but it is related to the internet speed. But all these we can call it the internet speed, not at 7th generation or 8th generation. So anybody want to check, you can also check the internet speed. So top countries having the fastest internet, because we are talking about IoT, IoE, 5G. So the global average download speed has gone from about 9 Mbps in 17 to just over 11 Mbps in 2019. The average download speed in top spot Taiwan is 85.02 megabits per second, and that speed it would take someone must 8 seconds to download a high definition movie. In fact, Taiwan is one of the country when 3 years or 4 years before, when I went there as a keynote speech, then I knew that in all over the country, everywhere you can connect with the Wi-Fi, and of course it is free, right? So in fact, at that time I was not using, I was using my phone, but it was connected with the Samsung tablet. This was S2, and I was surprised to see that everywhere you can connect to internet. That is the first country in the world that this is provided internet in throughout the whole world, throughout whole country. The top 10 countries in terms of the internet speed include the Taiwan, Singapore, Jersey, Sweden, Denmark, Japan, Luxembourg, Netherlands, Switzerland, and Norway. So if you want to see, you can see. So check that what is the difference between the 3G, 4G and 5G, and gradually we are going to our main topic, that how these are affecting to the sustainability, to the new devices which we are going to deal with the IoT and IoE in the 5G generation. So if you see a comparison, you cannot understand that how the 5G is impacting those devices until you don't have a very clear discrimination about what's the basic difference. So if we all are the ICT guys, so we may better understand, but because our area is very focused in a particular specific topics, so we may not bother, or we may not may not be aware about all those things. So 3G, which is in 2004 and 5, then 4G is coming to 2006 and 10, and 5G we can say that it is 2020 is the year of the deployment. In terms of the bandwidth, you can see that in 2004-5, 2 Mbps. Into 4G, it is 200 Mbps. I remember that when I left India, it is 2005, and at the time this was only the broadband connectivity. We got it from the BSN and BSNL, and at that time, even though I don't remember that what is the exact, it was what is the exact speed, is the bandwidth. Now you can see that in the 5G it is 1 Gbps. Latency means how much fast you can download the things. It is 100 to 500 milliseconds. In the 4G it is 20 to 30 milliseconds, and in 5G it is milliseconds you talk it. In average speed, if you talk about it, so in 3G it was 144 kbps, in 4G it was 25 mbps, in 5G it was 200 to 400 mbps. Also, a lot of concern, a lot of issues they are coming up with the, what is the 5G and the health concern. A lot of discussion even on the BBC, on the world level, that several of the scientists, even though researches are going on, and that's why I also investigated and I also worked on as a researcher, that what is the exact things, what is the exact impact of the 5G to the health concern. To understand this one, in fact, you have to go into the root of those bandwidth and see that what are those effects in our normal everyday life. So 5G uses high frequency waves than earlier mobile networks of the radio waves. Still, we are in the radio waves. If you have remembered something from our intermediate, in our 12th class, we know there is a band. I will show you. Previous versions 1G to 4G uses the lower frequency of the radio waves. Lower frequency. Radio waves are the waves of electromagnetic radiations with the wavelengths in electromagnetic spectrum longer than infrared light. They have frequencies from 300 gigahertz to as low as 3 gigahertz, and corresponding wavelength from 1 millimeter to 100 kilometers. This is the range of the radio waves. So radio frequencies radiation, which include the radio waves and microwaves, is at the low energy end of the electromagnetic spectrum. If the RF radiation is absorbed by the body in large amount, enough large amount, of course it can produce the heat. This can lead to the burns and the body tissue damage. However, chances of such harms is extremely less. How it is? I'm going to prove it. See the whole spectrum of the electromagnetic waves in the next slide. This is a wave, electromagnetic spectrum. If you see that in the extreme end is the radio wave. So we are talking about where the 5G is between the radio and microwave. So it is increasing from if you see the wavelength in the centimeter, it is going to be very small towards the microwave. It is in the microwave, it is in 1 centimeter. In fact, it is in exact 5G works up to the 10 mm. Infrared is 10 to the power minus 2, visible is 10 to the power 5. So up to the microwave, you see that these are going to be more and more dangerous for the health. If you see that radio waves can cross the buildings, they can cross the humans. Microwaves is also the honeybee, they can, because it is 1 centimeter. Infrared, it is the pinhead. and then visible molecules, atoms, and atomic nuclei. So gamma rays are going towards that side. So there is a word that non-ionizing nature of the radio waves. The radio wave band used for the mobile phone networks is non-ionizing, which means it lacks sufficient energy to break apart the DNA and cause the cellular the damage. This is in a report from the BBC 2019. Higher up the electromagnetic spectrum, well beyond these frequencies, there are clear health risks from the extended exposure. The sun's ultraviolet rays falls within the harmful category and can lead to the skin cancer. This is a major point. I will show you some more slides and it will be more clear. Actually, the sun does not only produce the infrared, but it also visible light and ultraviolet visible light fusion in a core actual gives off high energy gamma rays. By the time they get to the surface, their frequencies are mostly only within the infrared, visible, or ultraviolet spectrum. During the solar flares, the sun also emits the X-rays. So that's why it is highly recommended not to be a direct touch with those sunlight during the solar eclipse. So how it is connecting with the 5G and radio waves? There is strict advisory limit for exposure to even higher energy radiation level such as medical X-rays and the gamma rays. You know that when I was child, my father comes to the hospital, they always say me that, okay, don't go to the X-ray room. I couldn't understand what he is talking about. What is the harm to go near to the X-ray room or something like that? But now when we learn when we grown up to the intermediate, we start understanding that you cannot see the rays, but they are still in existence and they are going to harm you, which can both lead to the damaging effect within the human body. People are understandably concerned over whether they might evaluate their risk of cancer, but it is crucial to note that radio waves are far less energetic than even the visible light we experience every day. See the full electromagnetic spectrum. Again, once again, you can see that it is a radio, mobile phones, and microwaves. They are in the non-ionizing radiation. Non-ionizing radiation means they are not going to affect to the human body, and ionizing radiation are coming starting after the visible light. You can see that ultraviolet, this X-rays and gamma rays. So from lower frequency to the this frequency, and you can see this 5G is only from radio waves to the microwaves. So it is very clear that this 5G is in non-ionizing radiation. So the point is that even though the sunlight, this is emitting up to the X-rays, sometimes they are emitting to the gamma rays, and we are all facing the sunlight every day in everyday life. They are not harming. It is true that up to when they will reach to the surface, this frequency, this strength is going to be very low, but still those contents are there. 5G utilizes millimeter wave technology. This is in fact the 10 mm around, from 1 to 10 mm around. These millimeter waves exist on an extremely high frequency and consider millimeter waves because the wavelength ranges between 1 to 10 millimeter. 5G may also utilize ultra high frequency radio waves. This is the same thing, wavelength and frequency. We all know the formula, and it is between the 300 megahertz to 3 gigahertz. So radio frequencies from navigational transmissions, AM, FM radio broadcast, television, cordless, mobile phones, microwave ovens, satellites, uplinks, microwave relays, and radars all operate within the range of 3 kilohertz to the 300 gigahertz only. So theoretically, these frequencies do not carry enough energy to exert to the biological damage. So again, you can see this one. So if you see that energy of a one photon, which is on the top, then frequency from 3 hertz to, if you see into the this region up to the radio frequency, this is non-ionizing, and in the red portion in the ionizing, which is in the sunlight, it is a part of ionizing, means it is going to be effect, and that's why it is suggested that in the extreme hot weathers you should not go out. So this is the visible region. In fact, if you can see that this is 400 to 700 nm, and you can see that it is between the infrared and the ultraviolet, and our 5G, which works into the radio frequency and the microwave. So it is clear discrimination because it is coming from 1 mm to the 10 mm. So it is very clear that even though the other question is that even though microwave, we are using, everybody's house has a microwave. Okay, we have the phones, we have the Wi-Fi, but we are not caring that they are going to harm anything. But when it comes to the 5G, we start saying that maybe it is going to affect a lot. So what are the health concerns? If you look at the chart in the previous slides, you will see where millimeter wavelengths are situated right in the middle of the chart, and look at what electronic devices use millimeter waves. Microwave ovens, for example. Microwave ovens has been used in homes for decades, and that also means people have been using millimeter waves inside their homes for the decade. So people now understand that using microwaves may not be healthiest things to do, but no one actually panics over the use of microwave ovens in their homes in the same way that they worry about the 5G. Should they? So that was the concern with the 5G, and all these are going to impact on the sustainability development. Again, the sustainability development, in fact, the United Nations UN goals they have developed in this 2015 to 17 sustainability development goal to how to sustain with coping with these all those modern technology, means starting with we have machine to machine, we reach to the Internet of everything, and in the same way we have the 1G, 2G, 3G, and we are in the 5G. We are also talking about the next generation, but how they are impacting to the intelligent devices. Intelligent devices are those devices which are also helping for the sustainability development of any of the nations, especially we are talking about the developing countries. So sustainability is a development that satisfies the needs of the present without compromising the capacity of the future generation. So concept of the sustainability development appeared for the first time in 1987. In 2015, 2030 agenda for the sustainability development was introduced by United Nations Development Program. So first we have to understand what are the sustainability development programs, and it is all about for the development and sustainability for those utilizing those, how they are going to utilize this advancement in the technology. So number one is, what is a major problem in the world at this time? The no poverty. The second one is the zero hunger. The third one is the good health and the well-being. Fourth is the quality education. Fifth one is the gender inequality. Sixth one is the clean water and sanitization. Seventh one is affordable and clean energy. Next one is the decent works and economic growth. Ninth is the industry, innovation and infrastructure. 10th one is the reduced inequality. 11th one is the sustainability cities and the communities. Next one is the responsible consumption and production. Next one is the climate change, then life below the water, life on land, then next peace, justice and strong institutions, and then partnership for the goals is the last one. So if you see if you give the attention to this figure, you will find that for us, especially for the developing countries in Africa and Asia, that these first 6 goals, which is on the top, they are of the major concern to the developing countries. No poverty. Yes, poverty is a major issue in majority of the developing countries. Hunger. It is very good that the India has, we win on the hunger. I think from the government data, nobody is going to be hunger. Good health and the well-beings. Health is also one of the major problem in the developing countries. Quality education. Quality education is one, again, the challenge in the developing countries, because Even though for our beloved country, India, you can see that I think, I don't know, more than 10,000 or 100,000 engineering colleges are there. There's a no any quality education, no any quality teachers are there. They are just coming here and there. They are producing, they are teaching to the students how but quality education in all, it is one of the major issues, even for the PhD theses from various state and here and there universities in India. Gender inequality, this is again one of the basic issues, especially in India. I was in a flight, I think from America to the South America. I met with a Chinese, and Chinese, that lady was saying that I want to travel all over the world, but I fear to go to the India. I say, why India? He said that no, there is a risky, there is a lot of rapes and other things. This is a small image of us. I say that it is not the truth, because once all those countries, for example, all South American countries, they are not very, they are risky, there is a robbing and this or that one, but they are safe for the ladies. Gender inequality, clean water and sanitation, a lot of countries, even in Africa, in India even as well. So if you see, these first six are going to be the major goal for us. Of course, the clean energy, decent work, industry, required inequalities. This is also the plan, but it is more concerned with the developed countries. So different type of the sustainability. There is a basically three type of sustainability is there. Environmental sustainability, environmental conversations, investment in the renewable energy, saving water, supporting sustainability, mobility, innovation in sustainability construction, social sustainability, this is the development of the people, communities and culture, gender inequalities. And third one is the economic sustainability, economic growth, including employment generation without harming the environment. So why it is the importance of the sustainability development? That is due to the proper use of the resources, use of the mineral oil, drinking water, insecticide, chemical fertilizers, forest products should be minimized, help to conserve and promote the environment, improving the quality of human life while living within the carrying capacity of supporting ecosystem, balance our economic, environment and social needs, allowing prosperity for now and future generation. Sustainability development can also produce more financially sustainability economic, such as gain access to the free and accessible energy through renewables. So how the 5G is impacting to the sustainability? So if you see that ultra fast 5G wireless networks has been widely touted as a potentially transformative development on par with the advent of the electricity. This is not mere hyperbole. One area where the 5G will play a decisive role in the progress toward achieving the 2030 agenda for the sustainability development adopted anonymously by the United Nations in 2015. So what are the advantages in the mobile technology, including rapidly growing 5G? The latest generation of the wireless tech can help enable achievement of the following SDG, especially for the goal 8, 9, 10, 12, and 13, decent work and economic growth, industry innovation and infrastructure, goal 10, the reduce inequality, goal 12, responsibility, consumption and production, and the climate change. So starting with the decent work and economic growth, a 10% increase in the mobile broadband adoption means 0.08% increase in the nation's gross domestic product, according to the research conducted by Ericsson and the London's Imperial College. So how it is going to be affected the 5G? Goal 9, it is also affecting with the industry and innovation and infrastructure and reduce the inequality. Half the world population already have access to the internet. The next 50% will be connected by the broadband, and the 5.9 billion mobile broadband subscription worldwide today will surpass 8 billion by 2024. Many people have the multiple subscriptions. This will enable social and economic inclusion and help to meet the social need in the education, health, e-government and entrepreneurship. So it is also affecting to the goal 12, responsible consumption and production. 5G technology will enable the factories to be more flexible, safer, energy efficient and cost effective. It is also affecting to the goal number 13, which is related to the climate change, related to the digitalization of range of services and industries which will be added by the 5G can help to reduce the greenhouse and gas emission by up to 15% by 2030. So how again we are returning back that fog computing and how they are impacting the cloud computing and Internet of Things has changed the way of conceiving the IT systems IoT cloud to indicate the distributed complex system which is able to provide IoT as a service. IoT as a service. If we are working in cloud computing, we know only the three type of services. But now you can see that a new terminology, that is IoT as a service. At the edge of the system, multi-sensor electronic devices make smart the things they control, also enabling the interconnections with the remote cloud infrastructures, platform, or the software through the internet. So the cloud computing and Internet of Things has changed the way of conceiving the IT systems. IT cloud to indicate the distributed complex system which is able to provide IoT as a service. As the age of the system, multi-sensor electronic devices make smarter things. They control, also enabling the interconnections with the remote cloud infrastructure, platform, or software through the internet. So achieving energy awareness to the IoT as a service is a challenging, which needs appropriate choices in all the environmental, economic, and ethical aspects of the sustainability. The use of fog computing can help to discover new businesses opportunities, taking into account the above green goal. So sustainability, fog computing is the most prominent solution for most problems occurring in the cloud data centers, such as the latency, security, carbon footprints, electricity consumptions, and so on. It is an extended design of the cloud computing that supports the horizontal computing paradigm, providing the cloud-like services at the edge of user premises. After emerging, IoT for computing has become the first choice of the time-sensitive applications due to its residing closer to the devices and the sensor. Fog computing can achieve the sustainability through the fog in several application area. So if you see that in beginning, we started with the clear discrimination between the machine to machine, then Internet of Things, and then we go for the Internet of Everything. Once we understand between the three basic concepts of Internet of Things, Internet of Everything, we go for the edge and fog computing, because all those things, they are going to be how they are going to this massive data, how when we are going to deal with them, either at the edge or at the fog. At the edge means at the system, at the node, but in the fog means it is going to be on the LAN. But not everything can be done at the edge. So we always require something to send on the fog to the LAN. And then we are entering to the 5G. And you know that when the 5G, everything means Internet of Things, people, process, machines, everything is machine to machine, machine to people, people to all of them, they are must. So we are producing massive amount of the data, and how we are going to deal it. So now the sustainability appears, because you need to sustain the things in a proper way when we are dealing with so huge amount of the data. Then the pros and cons of each technology are also presented. Now we will see that how the United Nations 17 Sustainability Development Goals are summarized and evaluated against the emerging technologies. So when we are talking about the intelligent system, we are talking about the new development based on those new generation, 5G generation. Then it is examined that how emerging technologies are helpful in achieving the sustainability development goal. So these are the references. If you go through this, you can have some more interest, but these all those slides which I have shown you, they are the means you can. If you see some of my publications, we are targeting at this time how the new emerging technologies means up to the 5G, they are impacting to the sustainability development goal. In fact, one of my students, he just graduated from University of Alcala, which is the implementation of ICT technology for attaining sustainability development goals in Africa. So this on each of the 17 goals, maybe you can produce several theses on that one, that how you are going to attain the sustainability development goal. And a lot of work is still required, especially for the developing countries like India, in Africa as well. So these are the things, these are my references. You can also see sharing some of the conferences. There are several calls. I think only 2 calls is present in fact some of the books in the Scopus Index, in IoT series, in some of the EI. This is blockchain application is still there. And the last date is the 30th of the April. And also we have some date for the new frontiers in the IoT and cloud computing for post-COVID era. We are collecting the papers for that one. This book is in IoT series and it is in Q2. It is one of the top series. Remaining 2 are closed now. So you are also welcome to submit your papers in IJSCIP, who are working in the human capital and information technology profession. It is a very old journal, more than 11 years now, and it is indexed in Web of Science and Scopus. Also a book series since 2010. I am editor-in-chief of this book series in IGI Global. You are welcome to submit the proposal of the book, and you can see this call for papers in those ones. Thank you. Thank you so much. So I am giving you still I have 9 minutes to reply your answers of any of your questions. Thank you so much.
So any questions from the audience? Professor Mishra has given an excellent lecture covering different aspects of sustainable development. So I think that there must be some queries or comments regarding his lecture. Is there any?
Yes. Please ask questions. This is very, very means I gave this lecture several places, including the US. One of the university in the US as a physical, not as a virtual 2 years before. They invited me and it was really appreciated because we are connecting a lot of things, new researches and a lot of potential for the new topics, because this is one of the challenge in the developing countries, that in which topic the students will work so that it can be attract a lot of citation and other things. So the sustainability development goal, and on the one side and then on the other side you can talk about these IoT, IoE and all those devices. So it is a very good combination that you can merge it, you can marry it, and then you can do a very good research. If you want, means we have a lot of papers on sustainability. I think at present 30 or 40 papers we have published on sustainability, including some of the top journals from elsewhere, sustainability journals, and like that. If anybody wants to discuss about this one, this is
Professor Mishra. Professor Mishra.
Yes.
Can you hear me?
Yes.
Can you hear me? Yes.
Yes,
Yes, I have one query. Do you think that there are some areas where the agenda places can be extended? Because you have already given 17 points regarding the agenda.
Yes. Mm-hmm.
So are there any points, for example, in the recent advancement of pandemic in the entire world, will the agenda be extended regarding the medical aspects? Do you think so?
Yes. So if you see that, this is one of the agenda, good health. If you see that, it is one of the agenda in the good health, and that is a very wide concept. And of course, you can. There is a direct relation between the sustainability in the majority of the developing countries. In fact, in this pandemic, thanks God that this pandemic was for the rich countries more than the poor countries. For example, Africa is the least affected continent at this time due to this pandemic. We are in session since September. Our schools are open, and I'm taking my classes of more than 300 students for some of the combined classes. Right, so we are in full session. Universities are open. We have more than 7,000 students in our campus. They are living in the hostel. There is nothing. There is nothing except you are going to the hospital. You need a mask. Otherwise, there is any mask culture as well. The issue is that up to the last year, before last March was my last flight to outside. So we cannot travel outside. That is only the issue. Otherwise, so this is a point of the research as well, that why we are like India, but we are more. I also did some research, for example, why the Africans are least affected, because still they are very close to the nature. There is no Domino's, no Pizza Hut, nothing. It's still could not capture to the African market. There are, but they are very limited. But in India, you can see chips, Coca-Cola, this or that one. Here, still they are eating their own food. If it is a king, he is still eating the same thing what the poor guy is eating. So they are eating really they are with the nature. And that is the effect of their lives, that is still this pandemic could not affect much. Otherwise, the situation will be more than worse. You understand? But in India, for example, we are also very cultural countries, but we have left our own culture and we are living in the modern society. You know that. So not much to say. But these are the things of several things to the research. So this is already included in the good health, one of the agenda of the SDG goal.
Okay. Thank you very much. Any question from the audience?
Do you think that radiation problem will hamper the implementation of 5G or 6G?
No, it is not hampering, because this is a misconception that some radiation, due to the radiation, the researches are going on in especially UK, in some developed countries in Europe and America, but there is a very less effect. It is the same case, for example, AstraZeneca has been banned in UK and in some of the European countries. Even now, Germany and some other countries, they have banned, because they are saying that it is a blood clotting. Maybe the blood clotting is coming through another way. This is the same thing in the 5G, that the radiation is affecting to increase cancer or something like that, but it is not affecting at all. I have shown you a lot of pictures to make it clear that, in fact, 99.999%, it is not going to affect anything. It is not.
Okay. Thank you, Sanjay. Sanjay. Thank you.
We must thank Professor Mistro for his excellent lecture. And now I am handing over the mic to Devashish.
Yeah. Thank you, sir. Thank you for your nice way you have conducted this session. And thanks to our speaker, Dr. Sanjay Mistro. Now we are waiting for TCS team, Tata Consultancy Services, for Innovation Lab by Tanusham Chattopadhyay. Tanusham will basically conduct the session, industry session related with IoT. I hope everyone will enjoy. Please join the next session at 3 p.m. with Tanusham Chattopadhyay and his team of Tata Consultancy Services.
Okay, thank you so much for your cooperation and arrangement. I was interested to see you all in a physical meetings in the conference, but maybe in the future, if the pandemic will go. Thank you so much. This is so early, so I am going to take a cup of coffee. In fact, I have not taken the breakfast. Sorry for that.
Sorry for
Okay.
disturbing you the early morning.
No, it's okay.
Yes,
It's
yes.
okay. This time is okay. It's okay. It is not. But you know that we are here. You cannot find everybody is in the church as well today. So it is very calm surrounding area, but it's okay for me. Thank you so much.
Thank you. Thank you.
Okay. Thank you so much. Bye bye.
Bye.
Okay,
Bye-bye.
thank you,
Thank
Devajish.
you, sir. Thank you, sir. Please join our next session if possible. Yes.
Okay,
Thank you.
Hi,
Starting-
Tanusham here. We are
Yes.
going to start. Just 1 minute is left. It's 2:59 right now. So
Oh,
let me set the context. I think that making a bit earlier is something against the so-called culture of Indians and Bengalis, but still, for the industry session, it's perfect possibly because punctuality is something we have to strongly adhere to every time. So we can start if all the participants are ready. I'm not switching on my camera because it may hamper the presentations. So let's start the industry session. We'll have we'll divide it in two parts. First one is a plenary talk by Pratib Misra from TCS, who is owner of the product of TCS IoT Analytics named TCS Connected Universe Platform. He will first deliver a talk on IoT edge computing, followed by there would be a panel discussion on the IoT for advanced manufacturing, and this will be covered from three different aspects. Typically, any industry session normally consists of only the use cases and the scenarios, whereas the academic sessions includes the papers and results of their some academics interest. But here in this session, it will be covered from three different aspects. Professor Suryakanta Pal from IIT Kharagpur, he will speak about the academic perspective of this advanced manufacturing, whereas the Dr. Arpan Pal from TCS Innovation Lab, who is owner of the who is heading the TCS research in the embedded systems and robotics, he will speak about the same thing from the industry perspective. And finally, and business overview will be focused by will be covered by Dr. Purnendu Shinna, who is from Tata Business Group. So now it is over to Mr. Pratib Misra. Before inviting Pratib, you can. Do you want me to present the screens, or you will present your screens?
I will present my screens.
Okay, so let you set up that screen. By that time, let me give a brief introduction to the speaker, Mr. Pratib Misra. His camera is on, so we can see him on the screen. And let me tell a bit on Mr. Pratib Misra. He is the head of technology and engineering and chief architect of the TCS IoT platform, TCS Connected Universe platform, known as TCUP. He has over 28 years of experience in software engineering, research, and technology consulting. As a thought leader in TCS R&D organization, Pratib has been responsible for setting up Center of Excellence COE in the areas such as stream processing, storage system, RFID, and digital signal processing. His areas of expertise include embedded systems, RFID, IT infrastructure, real-time analytics, and cloud computing. He holds a BTech and MTech in electrical engineering, both from the Indian Institute of Technology, Kharagpur. He attended executive leadership program conducted by Michigan Ross School of Business. Pratib was awarded the TCS Research Distinguished Engineer Award in 2018. He has authored over 10 international patents grant and over 20 international publications. Now it is over to Mr. Pratib Misra, and hope that the audience will be really, will be enlightened with his vast experience in industry and the real implementation skill of that research. Whatever he has done is really implemented in some product. He's owning the product of TCUP. So it's over to Pratib Misra.
Thank you, Dr. Tanusham. the way I would put it is, this is more of an exchange, just to share with the academic community and with students on what is happening on the industry side. What are the kind of things that we are interested in, and what kind of work that we do, what and our customers, what kind of work that industry company like TCS is doing in this area, and what our customers are interested in. So this is to be seen as an exchange. Tanusham, I guess I have, how much time do I have? Do I have 40 minutes?
Uh, 35 to 45
35
minutes and then question answer. Any
Okay.
45 minutes, up to 45 minutes you have.
Okay, fine.
So,
I think I'll finish before that. Right.
And I've seen Orpanda is also already joined. So if the question answer comes, we can have, I mean, both of you on board for that time.
Right. Yeah, okay, sure. Yeah, thanks. So this as this is a talk on IoT edge computing, and specifically I will also be giving an introduction to something called the Teacup Edge, which is TCS Connected Universe Platform Edge, which is uh, the edge part of the platform, the IoT edge platform. And this is a product from our company, and it's now part of it is organizationally, myself and this product is part of the TCS Manufacturing and Utilities Business Group. But of course, this product has applications in other industry verticals as well. For example, we do a lot of work in life sciences. We do work in transportation, etc. Apart from manufacturing and utilities, even in retail, we do work, right? So this, what I'm talking about is industry agnostic. It is a horizontal technology, and the platform itself is horizontal. So the way to look at this is less of a lecture or introduction. I think most of you here are already aware of IoT and IoT Edge. Professor Sanjay Mishra, who just spoke before me, I think he also covered a lot about fog and edge. So I'll start with a very gentle introduction to IoT Edge and an IoT Edge platform, and then go into exactly what this product is, and also some of the work that we have done. Uh, so of course, I think we don't need much of a introduction to IoT, but it's essentially about connecting the physical world to the digital world, and then enabling this connection, this sensorization to observe in real time the state of the real world out there, the physical world, and then use that information for optimizing. Also, like as Professor Sanjay Mishra said, enabling all the sustainability development goals, etc. So whether it is energy efficiency or operational efficiency, or simply providing better user experience to end users. So we generally see two classes of applications, one which is more of consumer facing, the other which is more business facing, so which we call as industrial IoT. In our company, our work mainly is around industrial IoT, because most of our customers are large companies, and our focus is therefore industrial IoT. Industrial IoT has certain nuances and characteristics which are different from consumer IoT, although there are quite a few things which are common. But we ourselves, we are more interested in industrial IoT, where the focus is more on large assets, monitoring large assets, sensing more assets, and then production processes, business processes, and then how IoT can help on those things. Right? This talk is, of course, not on IoT and not even IoT platform, but very specifically, this talk is on IoT Edge. And so what exactly is Edge, IoT Edge? We'll again, take a very a set of few examples of what the IoT Edge is. Uh, Let me minimize this video window. Yeah, okay. So we see IoT Edge, of course, in the real world, the actual things that are of interest to us, like there are given some examples are given here, like in agriculture, we are interested, let's say, in soil conditions or growth of a plant, or the health of the vegetation. In assets, we are interested in how they are functioning. We can have completely mobile assets like robots. We can have human subjects who we are. So we find that there are IoT devices that are actually right at the site of our interest, and the IoT processing that is happening is what we call as the IoT edge. It's called the edge because it's at the edge of the network. So typically in industrial IoT, we have these three tiers, you can say, or four tiers if you also include what Professor Mishra said, fog. But I'll combine fog and edge. So there is this edge tier, which is closer to the asset, probably in the same network segment as the asset is. And then you have the platform tier, which is the middleware which is required for IoT applications, and then finally the applications tier. So here our focus is on the edge tier, where there are the things of interest are, and our IoT related computing and processing is happening close to the asset itself. And then there are some more examples here. We can see a smart factory where robots are involved in certain manufacturing, or even intelligent machines are there. Then we can see an example from a petrochemical industry where there are large number of connected assets, assets that need to be connected and monitored. Then even examples like kitchens, commercial kitchens have equipment which are connected and sensorized, and we are acquiring data from there. And then workers as well connected, so people working in factories. In fact, all the pictures that you see down below are actual projects that we have been engaged in. We have worked in these kind of areas. Right? So these are examples of the edge locations and the assets involved in the edge. Right. Now, if again I was talking of these architectural layers, this picture probably not a very good picture, but it will give you an idea of what the three layers are and where edge resides. So we have the edge layer where the network that operates in that edge layer, we call it as the proximity network, because it is used to connect to the actual sensors or devices that are attached to those assets, right? So, for example, you can have various kinds of wired networking protocols. In the industry, in the factories where we work, there are these industrial buses like Profinet or Field Bus or Modbus. So these are examples of proximity networks in industrial IoT. Similarly, in consumer IoT, you can have interfaces to technologies like Bluetooth or Wi-Fi, etc. So this is the edge, and the IoT edge. Actually, we are interested in the computing and the processing that happens at this layer. And then in the middle, you have the core, the data center, where the bigger pieces of computations, whether it is storing of the data in large databases, or whether it is processing those data to build models or analysis or run simulations. That's the kind of work that is happening at the core layer. Typically, it's the company's back office, or it's a data center, or these days it's more often than not to do it in cloud. Cloud meaning public clouds like Azure or AWS, or even companies' own clouds which they have. And then we have a fog layer which is in between. Sometimes the computation is further divided into this fog layer and etc. Right. So the actual assets are closer to the edge layer. You can see whether it's a industrial machinery or factory or buses or cars, vehicles, people, buildings, all the things that we are interested in, those are connected to the devices and systems that we have at the edge layer. And today our focus is on the edge, right? So let's try to see some of the characteristics of the systems that we build on the edge and why we need them. So one of the things is that many applications need low latency and real-time response. For example, consider an autonomous car. The autonomous car has to maintain its lane, avoid collisions, detect road signs, maintain the speed. So these are all control systems with absolutely hard real-time deadlines, and the sensing, processing, actuation, all of these need to maintain those hard real-time deadlines. And the computation that happens in those IoT edge devices, IoT edge devices help us in ensuring the hard real-time responses, right? Because if we had taken the computation to the fog or to the cloud, let's say I am running a control algorithm, if I have to do part of it in the cloud, but because of because it's not deterministic, the time that will take for me to transport my data to a computer in the cloud, run the computation, get it back, right? So these kind of computations are never done that way. These hard real-time computations, those requiring low latency, like image processing and correction, let's say, for example, all those kind of computations happen at the edge, right at the site where we have complete control over the latencies. The other characteristics very common is that we lose connectivity, and we should be able to work when there is no connectivity. And again, that's where the edge makes a lot of difference, because if we had to depend on network communication, then some of our applications would simply not work. For example, again, if I have to drive a self-driving car through a tunnel and I lose my connectivity to my cloud, then it doesn't work, right? So I need to have the computation right there, so that whenever there's an intermittent or even no poor network connections, my application and my business objectives are always maintained. Another example is we need to work times in what we call as demilitarized zones or air gap networks. So take the example of this picture, like it's a classical medieval castle or fort which has a moat around it, waterways, and this it's essentially you can't enter that except through very well designated paths. So this is like a DMZ, or demilitarized zone in computer network terminology, and uh, these they don't allow you connectivity. Simply put, you may have to run your computing where there is no connectivity to your back office or to the cloud. All the computation needs to happen, and sometimes even that is not there, and it is completely air gapped. So edge, again, you need edge computing, IoT edge computing, because these are the kind of scenarios that we face, and this is a very common scenario, I can tell you that, right? For example, we are working for a company that makes motorcycles, and the motorcycle is going to have an IoT edge devices, which is capturing various kinds of sensor and engine information. And there will be times where there is absolutely no network connectivity, right? Or it's completely air gapped. And similarly, it's very common in factories to have a different operational technology network, and information IT networks are completely separate and managed by different teams. And there is very regulated connectivity between the OT network and the IT network. Similarly, resource constraints, like in IoT edge systems, we need to work on devices that are low in power in terms of computing, memory, etc. So the software that we write on edge devices, IoT edge devices, has to be extremely optimal and efficient, and work within low footprints of either memory or computing or even battery power. So that's another very important characteristic of edge systems. So in the IoT edge, we really have certain goals. We need to meet latency requirements, because the applications demand it. Uh, there is a huge integration challenges. In fact, for companies like ours, when we work in IoT, one of the biggest challenge for us is to integrate systems. I mean, integrate different kinds of assets uh, to other assets, as well as to other backend IT systems. because there are a huge heterogeneity in terms of the networks, the 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 structure of the data that is exchanged, the semantics of the data, uh, the networking protocol itself. There is so much heterogeneity. We spend disproportionate amount of time in integration, and therefore again standardization is very important. And but again, standardization is something that is required probably in every different vertical, because even within a given industry vertical there is so much variation and variability. So this is really a challenge. We also need to optimize on data volume and traffic, network traffic, how much to exchange, whether to do more computation on the edge or to the cloud, or how much data to exchange. All of those has to be optimized based on the project objective. And the use cases definitely is to enable remote operations of the remote assets, providing personalized, uh, I would say, experiences to people based. IoT Edge enables that, providing different kinds of experiences to end users. And of course, IoT Edge enables different kinds of use cases. So uh, there are lots of interesting things that are possible because we can do computation on IoT devices and edge and analytics at the edge, etc. So IoT Edge typically helps in meeting all these things, right? Uh, so again, this is also an example of the kind of IoT edge devices that we work with. I mean, these are just examples, but these pictures are just to give a flavor of the kind of systems that our customers use or we ourselves use for our customers. So there are these standard IoT gateway devices. So you can see there's one on the left from Dell, another company called Eurotech. These are all some of our partners that we work with. These are very classical IoT gateways, very, very common. They contain an embedded system. There is an operating system running on these devices, and our computation, our the software, including the middleware, which I'll be talking about. All of these, they run on these devices. There are some devices like this Lenovo device, which is an integrated device of a sensor and a edge device. For example, in this case, the sensor is a camera. So it's a camera and a gateway integrated. And then there is one on the extreme right on the top. This is a specialized kind of IoT gateway for heavy equipment like cranes and industrial machinery, engines, for example. So these are ruggedized IoT gateways with sensors. Typically, they will have various kinds of accelerometers. They'll have GPS. Of course, they all of these have communication capabilities, but these are also extremely industrially hardened because it has to sustain all kinds of environmental conditions. And similarly, there are more specialized computers which are used. For example, this one from National Instruments is used typically in monitoring of very high value assets like turbines and big systems. So they have a lot of data acquisition, data processing, signal processing, very high rate sampling, again very ruggedized. So these are the different kinds of capabilities. Some other form factors you can see very like these are more of consumer devices. So the ones on the top are industrial devices, but ones below are consumer IoT devices, IoT edge devices. So you have this Samsung Home Gateway, which people can put in their home for smart home kind of applications. Then you have the Google Nest thermostat, again used for air conditioning control in the home. Then we can buy these OBD devices, onboard diagnostic device, which you can plug into your car and makes your car into a connected car. So these are all consumer devices which can be bought, and then it can be plugged in. Right. So these are examples of IoT edge. Again, inside those IoT edge, you have these kind of boards, like you have this Arduino or You have this Raspberry Pi. These are examples, of course, for prototyping, but finally you made a production system out of these things. These days, IoT edge devices are also coming with specialized hardware accelerators for deep learning and machine learning, right? For example, this device from NVIDIA Jetson contains accelerators for machine learning inferencing and machine learning production, you can say, where models are executed in IoT edge devices. So these are again some specialized devices for automotive, etc. So these are all examples of the systems that are there inside those packaged things which we saw earlier. So what does the IoT software stack look like? So of course, they are computers. IoT edge device is a computer. It will have its hardware, device drivers. Very important is to have the right kind of hardware abstractions or board support layer. In fact, whenever one of these boards come out, we need to ensure that the hardware abstraction layer is there so that the device drivers can work. And on top of this board support package or hardware abstraction layer, we have operating systems. These days, it is extremely common to have Linux as an operating system. In fact, there are specialized operating systems for domain. Linux Foundation, for example, is coming out with automotive grade Linux which is specialized for automotive systems. So we can, of course, we can have other operating systems also. In microcontroller based systems, you can have more real-time operating systems like FreeRTOS, etc. But sometimes you don't have operating systems also. But these days, more often than not, we have some kind of operating system or other. And then on top of that, we have these IoT edge platforms. So we have developed at TCS, we have developed one such IoT edge platform called TCAP Edge, which I'll talk about briefly. And then, of course, the applications, which are typically these are analytics applications, rule-based applications. Of course, they acquire the data through the devices, the sensor devices. Typically, they process it and they do some local control action, or they also integrate these edge applications also connect with the cloud, which is either the fog layer, the cloud layer. So all those network capabilities are also there, in form of tools. So when someone is working on an IoT edge, he'll be working on one or more of these layers. And in TCS, we are mainly concerned with the top two layers in this stack. Okay, going forward, what are the kind of software infrastructure we see? So I have mentioned about these operating systems. So some specialized Linux distributions are available for IoT edge devices. Even Microsoft has come out with a specialized operating system called Windows 10 IoT Core. Again, these are very becoming very popular. These kind of things, and then you have the middleware piece, like for example, many IoT devices use a protocol called MQTT or Message Queue Telemetry Transport, and you require brokers for that. So Mosquito is a very popular broker that we find in IoT edge devices. It's a MQTT broker. Then to connect to industrial systems, many modern industrial systems talk a protocol called OPC UA, and therefore we need OPC UA capabilities in industrial IoT edge devices. Similarly, robots these days are using something called ROS2, which is the OMG DDS protocol for communicating between robots. So various kinds of middleware things are there. And then what kind of programming languages? Very common to, of course, C, of course, very common. We are seeing a lot of usage of the Go programming language. Within TCS, we use all these languages. We use Go, we use Python, we use C. And these applications are also increasingly being packaged in form of containers like Docker or Kubernetes. We take those applications, package them in form of containers, and then run it on top of these operating systems. Right? So what some of the trends? Okay, of course, this is not an exhaustive list, but this will give you an idea of the trends that we also in TCS we are following and we are building into our product, already built in. And so one is AI at the edge, machine learning at the edge, which is typically machine learning execution or inferencing kind of workload. So models are built in the cloud. Those models are transmitted to the IoT edge devices, and then those AI models are executed at the edge. So we have a deep focus on all aspects of this within TCS and TCACA. And the other thing is the containerized applications are being packaged as containers, and those are then run on container orchestration systems at the edge. So things like micro Kubernetes, again, a popular container for the edge. So these are something that we have also adopted, right? The other thing which is also happening is that there is a continuum, because of these technologies like software-defined networks and service meshes, we can actually very seamlessly just focus on the service development. So whether it is an edge service or fog or core. So on the data and the control plane part of the service mesh, these are all freely interchangeable and usable and pluggable. So there's a continuous continuum between the edge and the fog and the cloud. So these are some of the trends. And there's a lot of work happening in all these areas in organizations like Linux Foundation and the Cloud Native Computing Foundation, etc. So again, everything is, the boundaries are actually getting blurred, if you will, the edge, fog, and core, etc. So that was an introduction to IoT Edge in general. Very quickly, I'll also tell you about TCUP Edge. So TCUP or TCS Connected Universe Platform is a complete enterprise-grade end-to-end IoT platform, and we provide various services that are required in developing IoT applications. We package them in the form we call as microservices, and we expose them as application programming interfaces. So application developers use our APIs to develop these applications. We have a specialized platform for the edge called the TCUP Edge, which is designed ground up considering the edge characteristics. So designed for low footprint devices, and I won't spend much time on this, but on TCUP Edge, essentially it's a lightweight, full function IoT platform for the edge devices, and it is installable on various kinds of commercial IoT gateways and devices, etc. We have a huge collection of networking protocols that are common in industrial IoT scenarios. So these help us to connect with different assets or machines, right? We have specialized capabilities for deep learning and machine learning at the edge. We use accelerators from some of our partner companies who provide specialized hardware accelerators for AI. And we spend a lot of effort in actually doing an automation with respect to completely onboarding of these devices and these applications with zero human touch, so that it simply works. So these kind of capabilities which is required to connect, which is connecting various industrial assets and machines to the cloud, bootstrapping, which is really about automated way of onboarding of devices without a human intervention. Security is extremely important, as you can understand, and how to do everything automated in a secure way is a challenge. So bootstrapping helps us to do that, uh, identifying the right server endpoints, then provisioning with the right security keys and materials, and then using those to actually make the connections. Then we have the ability to store and process time series data. So efficient databases for storing time series data. Most sensor data, as you can imagine, is time series. But of course, these days we also have a lot of vision processing at the edge. So it's not only time series, but also images and videos and such blobs. So we have the ability to collect these kind of things. And then, as I mentioned earlier, focusing on analysis at the edge, analytics at the edge. Another very important capability is to manage the device remotely and upgrade. So whether it's software over the air upgrade, SOTA, or FOTA, which is firmware over the air upgrade, These are important capabilities. One which is required for microcontroller based systems and other for general systems, SOTA and FOTA. These are important capabilities that are required. And then of course, cloud synchronization, the data that we have has to be synchronized with the cloud. So these are the kind of capabilities that we have built in. And very quickly, I'll show some real life examples that we have worked on with this Teacup Edge platform. So for a large oil and gas company, which has literally huge offshore stations, we have integrated their asset data from the edge systems to the cloud. So synchronization of asset data. So these systems have their own control systems and own systems, but we need a way to keep information from diverse such platforms, each having diverse systems. So the OT systems in each of these platforms are very diverse, but we needed a way to keep everything synchronized. So using capabilities of the edge in acquiring data from these OT systems and then keeping them synchronized in the cloud, so that we get a global real-time view of all asset definitions and asset changes. So these are large programs. For another company, they had industrial printers which are at customer sites, and our customer needed the ability to upgrade the software remotely and monitor it, send configuration data and menus. So these kind of asset tracking, asset upgrades, etc. Asset monitoring is again edge computing is used. Then in smart factory, which involves collecting data from control systems at the edge, running some data processing, pre-processing at the edge, and then finally sending that to the cloud for the cloud related processing. So again, this was done in a factory of a precision engineering component company. Similarly, for large steel manufacturing, raw material inspection is done using image processing techniques, where we try to detect impurities in the incoming material using image processing. And whenever those impurities are detected, we generate alerts, etc. And another area that we have now a big focus is laboratory IoT. So most pharma companies and chemicals and formulations company have significant investments in labs, whether it is the product engineering lab or the production or manufacturing labs. There are many assets, very expensive and high-end assets in these labs. So these assets themselves need to be monitored like any other IoT asset tracking application, but also these assets also generate a lot of data. So integrating all these systems, transporting this data into by processing them, harmonizing the data, and then transporting it into the cloud, and then maintaining the data lake and cloud on the cloud side. So these are the kind of engagements that are very much in demand these days. We see a huge interest in the industry for laboratory IoT, and our edge platform is being used in many customers for laboratory, right? So I'll end my talk here. I hope I was able to give you a flavor of what's happening in the industry and what kind of engagements and technologies that we are involved in. And I hope I finished in time, and maybe I have a few minutes for question answers.
Yeah, so it is open to the participants. If you have any question, please unmute yourself and ask to the speakers.
Okay.
Hello.
Yeah, go ahead.
Yeah, please.
To Pratik Mishra, that you have developed these devices. So when you're talking about edge computing, but in India, many places internet is not there, isn't
Right,
it? And
right.
also internet connectivity is not also stable.
Right.
So when the network is not stable, what kind of solution you are planning? Means without
see,
internet
that is
or
one, yeah. That is one of the design goals, like I showed you, that edge computing is especially useful when there is poor or intermittent connectivity. And the idea is essentially to distribute your applications and databases and storage in such a way that your business critical functions will continue even when the network is broken, right? So that's typically the way in which these systems are designed, right? So that business continuity is not hampered when there is a network breakage or a network. And the other use case, which is very common for us, is to deploy it in a factory site or a location which has no connectivity to the outside world. The network is completely, air gapped. So these are very common scenarios for us. Did I answer your question?
so so cache memory is playing a major role, or
Yes,
cache
yes,
memory, everything is cache
cache.
memory is
There are on the edge devices themselves, there are efficient implementation of databases and caches. You're right. We definitely use that. And yeah, message queuing is another one. Like if your connection is broken, you queue up the messages, then you play out. Similarly, on the other side, like there are concepts called device shadows. So let's say you want to send an instruction to a device and the device is disconnected, then you store all those commands, and then once the connectivity is re-established, you play them back in the sequence. So these are, of course, common techniques for handling these kind of scenarios.
So in academics, we do a lot of algorithm like resource scheduling, and also for PSO, GSO kind of thing. So or game theory also sometimes to select the devices and reject the devices, means in the selection procedure or resource allocation in edge computing domain. So
Right.
are you using the same kind of means technologies there in industry?
At present, the problems, sir, are very mundane in the industry, right? If I may call it, right? But there are a lot of practical challenges which we have to deal with. Like integration is a big challenge. Dealing with these kind of scenarios, network failures, database failures, systems getting, the connections getting broken, so we have to spend a lot of time in ensuring the robustness of systems, right? Monitoring and control is a big worry for us. Ability to observe, it's called observability, ability to observe all systems, the resource usage, not only of the hardware but each of the software infrastructure. For example, if you are using a message queuing, the resource usage within the message queues. If you are using a programming language like Java, the heap memory usage. So every aspect of the software systems on the edge as well on the cloud, we need a complete observability, which is metrics. And then since you cannot have human beings actually looking at those metrics, you need to set up rule-based systems to automatically take corrective or healing action, when things happen, right? So these modern orchestration platforms, which I mentioned, like Kubernetes, for example, these orchestration platforms come with a lot of capabilities, whether it is high availability or load balancing or observability. There's a tremendous amount of progress which has happened these days in both edge and cloud computing, and we are trying to make, our concern is to use the best state of the art technologies that are available. And of course, there are, I'm sure, if researchers get involved with us, I'm sure they'll find a lot of interesting research problems. I have no doubt about it. It's definitely there. But yeah, we are at present, our aim is mainly to use the currently available state of the art in the best possible way, because um, in the ground, even industries are not even adopted the current best practices and current state of the art technology. So even to get to that point, there's a lot of work to be done. There's a lot of legacy systems. There is change management, and everything has to be done without disrupting the current business. So there are lots of, so most of the time we deal with a lot of practical issues actually in ensuring that the current best practices are available and implemented.
So we are all talking about IoT, but in practical in agriculture or this kind of India, country like India, lots of farmers are there, right? We are talking about development or Atmanirbhar Bharat, but how much IoT is actually you think it is implemented in India? Means in terms of agriculture.
See, if you look at the history of India, there are large projects which you can actually call IoT, but we never called them IoT. Like some of my favorite, I have many favorite examples from India, and they have been there not today, 10 years, 15 years back, right? But we never called them IoT, right? For example, again, there are two specific projects implemented by our company. It was before we called them IoT. I'll give you two examples. One was a tsunami warning system, of course, done by an Indian government agency, but our company was involved in implementing that software, right? Then that is, by any definition, that's an IoT project. There were sensors out in the ocean, in the floats, and you have to do real-time, warning and data collection, signal processing, everything. By any definition, it was an IoT project, not done today, but probably 15 years back in India, it was done. The other is, you may probably know that there is a huge amount of automation done in our utility sector, at least at the distribution level. There are many of the states have completely sensorized and automated the distribution part of the utilities, where it's measured, monitored, integrated with the back-end ERP systems. These projects have been done, like conceived 10 years back, finished 5 years back. So a lot of work has actually gone in. I will not say that India these things are new, but of course there's a lot more opportunity for us to do, whether it's in the area of telematics, energy management, whether it is smart factories. Then of course newer applications like sustainability applications, green energy. So huge opportunities are there, and I won't say that it's totally blank. There are a lot of things which are out there.
Thank you very much.
Okay.
Other than Dr. Debashish, anyone have any question?
Mr. Pradeep, I'm having one question. MD Agarwal.
Yes,
the Tata Steel is way ahead in implementing the IoT systems now. Do you have any experience of, you or your team must have
Yes, sir.
done some implementation in Tata Steel. What kind of things they have put?
So there are many things done in Tata Steel. I have myself been exposed to two things, and I think Dr. Sinha is also in the call in the panel discussion. One of the projects was, I think his organization was intimately involved. Also, Dr. Arpan Pal is there. So one was this health monitoring of the condition monitoring of workers. Like smartwatch based Kavach. I think either Dr. Pal or Dr. Sinha after me can talk about it in detail. But our platform was also initially used in that actually. So this involved monitoring the condition of workers in harsh environments and detecting things like health condition or fall detection kind of thing. So that's one. And another one which I am aware of, because parts of our platform was used, was for resource monitoring, energy monitoring in one of the plants. And so that's one. And then there's a third one also, the impurity detection, which I spoke about, was also done in Tata Steel, jointly along with our research team headed by Dr. Arpan Pal and our team in the platform. So these are, but apart from these three, I'm sure there are many things in Tata Steel.
Yeah.
I'm probably not aware myself, but these three I'm aware of. And of course, Tata Steel Europe in Netherlands, they are also doing a lot of asset monitoring. I know one of the projects that we were slightly involved in was predicting the failures of large pumps. Dr. Tanushyam, who is chairing this session, also was involved in that. So this was about predicting the failure of scale pit pumps, etc. So here and there we have done a few things with Tata Steel, but I'm sure Tata Steel has lot many more things which I'm not aware.
Okay, thank you.
I
And
think
one more
some of them
question.
will be covered in future next session also. The next session is the panel discussion on advanced manufacturing, IoT for advanced manufacturing.
Okay.
So we can hold some of the questions from the
Okay.
next panelists. So, okay.
Okay. Yeah.
Any other question from anyone?
Yeah, if I can ask a question.
Sure, sure.
Actually, I just wanted to know, like, how can we leverage machine learning at the edge?
How can you see?
We can cut down the raw sensor data, and then also
That is one. See,
Yeah.
the biggest application area is in the area of image processing, right? Where you can high definition cameras can be used for detecting anomalies in your production line. It can be used to detect anomalies in your product quality, in your raw materials, and many other applications. I think there are huge applications of image processing in the factory, and all image processing in the factory means it's happening on the edge. And it means that you are using some kind of machine learning model to detect these anomalies or to detect those conditions, etc. So, extensive use of machine learning, deep learning at the edge, and in this case, the models that are built, standard models, image models, training models, uh, you customize them for your application through a process called transfer learning, and then the model that you specialize for your application, the model is downloaded on the edge device, and on the edge device, you use that model for only the inferencing or detection purposes. And to enable that detection, there are specialized hardware accelerators like companies like Intel, companies like NVIDIA. They have come out with specialized CPUs and chips and accelerators to facilitate inferencing at the edge, machine learning inferencing. I think we have experts here, Dr. Tanisham, Dr. Appan. I think they have spent extensive amount of time doing machine learning at the edge. They can tell you about it in more detail.
Basically, it's going to lower the operation cost by optimizing.
Bandwidth, everything, bandwidth costs, you don't have to transmit the entire image to the backend or the video. You are only transmitting the events that you have detected. That is one. The second is real-time response. The entire latency involved in transmitting the data back and forth, all that is eliminated. But even for time series data, whether it's like vibration monitoring or any kind of other anomaly detection, you can use machine learning at the edge. These days, people are using machine learning in microcontrollers. There is an entire trend which is focusing on machine learning for microcontrollers. For example, I heard a case study where within hearing aid, in hearing aid, people are doing personalized experiences using machine learning. And you can imagine hearing aid is a very, very low footprint device with battery power, and extremely efficient machine learning is being done for hearing aids and etc.
Okay, thank you.
Yeah. Okay, thanks.
Anyone else? Any other question? So if no more questions are there, so on behalf of the conference committee, on behalf of CSI, let me thank Pratib Mishra for his outstanding talk on edge computing. But I'll also request him to stay back for 1 more hour because the next session with our, Professor S.K. Pal, Dr. Arpan Pal, and Dr. Purnendu Sinha on for IoT for advanced manufacturing. Please stay back for 1 more hour because even here some question may come where you can also pitch in.
Okay.
And with this, we are completing the plenary talk session. And now let me introduce the panelists one by one. First of all, let me introduce Sir Professor S.K. Pal, Suryakanta Pal. I request you to please, switch on your camera for a while and say hi. And let me introduce him by the time. Professor Suryakanta Pal completed his graduation from Government Engineering College, Jalpaiguri, West Bengal in 1991. MTech from IIT Kharagpur in 93, and PhD from IIT Kharagpur in 1999 in mechanical engineering. Professor Pal has done 3 years of postdoctoral research at the University of Sheffield, UK. His current research interests include friction stir welding, Industry 4.0, modeling, and simulation of manufacturing processes. He started teaching at IIT Guwahati from July 2002 to July 2004, and then joined IIT Kharagpur, where he is presently working as a professor in the Department of Mechanical Engineering. Professor Pal has published 264 research articles, which include 156 international journal papers, 15 international book chapters, and 90 conference articles. He has also filed 11 patents, out of which 5 are in the area of Industry 4.0. The most recent patent filed by him is a low-cost AI-based Industry 4.0 solution for real-time metrological inspection. This patent is highly potent for MSMEs and is ready for commercialization. He also has filed 2 patents jointly with Tata Consultancy Services. Under his esteemed 17 doctoral scholars have completed their degree. At present, 19 doctoral scholars, 1 MS scholar, 3 MTech students, and 2 project staffs are working under his guidance. Professor Pal has also supervised nearly 60 MTech students. Professor Pal has executed a huge number of projects worth over INR 85 crores. Presently, he is serving as the chairperson of the Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur. He has been also awarded the prestigious Lord Kumar Bhattacharya Chair Professor in Manufacturing. He is also the Associate Dean of Alumni Affairs. Now, requesting Professor S.K. Pal to please wave your hand once. So, and also please switch on your camera just for a while, so that participants can just see you at least once before you start your presentation. And by that time, let me introduce the other speakers. Dr. Purnendu Sinha. Dr. Purnendu Sinha works with Group Technology and Innovation GTIO, Tata Sons, where he is engaged in fostering innovation in Tata Group companies in infrastructure and aerospace and defense sectors. He also leads Industry 4.0 initiatives at GTIO. He is driving research collaborations at the DHICOE on advanced manufacturing technologies at IIT Kharagpur in the areas of digital manufacturing and additive manufacturing. Dr. Sinha obtained his PhD in computer engineering from Boston University, Boston. That's MA. He is fellow of Institution of Engineers, India, and also a senior member of IEEE. An alumni of IIM Ahmedabad, he completed 3 TP Senior Leaders Program at IIM Ahmedabad. He is currently serving as chairperson of Program Review and Monitoring Committee PRMC set up by DHI, Government of India, for the 4 common engineering facility centers. He is a core member of the CII Smart Manufacturing Council, where he leads the working group in assessment. He is also the chair of manufacturing working group of Future Technology Tech Panel of IET India. So requesting Dr. Sinha to please wave your hand once. And the third panelist who will mostly speak from the industry perspective, Dr. Arpan Pal, who received both his BTech and MTech from Indian Institute of Technology, Kharagpur, India, in electronics and telecommunications, and PhD from Aalborg University, Denmark. Arpan has more than 29 years of experience. For last 18 years, he is with Tata Consultancy Services, TCS, where as distinguished chief scientist, he is heading the embedded systems and robotics research area in TCS Research. Prior to joining TCS, Arpan has led the real-time systems group in MacMet Interactive Technology Private Limited, and had been involved in design or development of missile seeker signal processor in Defense Research and Development Organization, DRDO, Government of India. His research interests include sensing and IoT, signal processing and AI, robotics and edge processing, with focus on building and deploying embedded sensing and control systems, products, and solutions. He has published 135 plus papers, book chapters, and books in reputed journals and conferences. He has filed for 150 plus patents and has 100 plus patents got granted to him in different geographies. He is inducted into TCS Patent Wall of Fame. He's two-time winner of Tata Group Innovation Award in the Piloted Technology category. Arpan is a senior member of IEEE and is engaged in the innovation space in different industry bodies like NASSCOM, CII, and BCC&I. He is on the review board of various government initiatives like IMP Imprint, CSIR Mission Mode Initiative, TIHCPS, etc. He has been on the editorial board of reputed journals like ACM Transactions on Embedded Computing Systems, IEEE Transactions on Emerging Topics in Computing, and Springer Nature Journal on Computing Systems. He is also on the TPC of top conferences like ICACA, UCIPCO, and on reviewer board for journals like IEEE Sensor and Physiological Measurements. With this, my introduction to the eminent speakers and the panelists is over. Now, I'll also have an additional request to Dr. Arpan Pal to please maintain this, serve as the panel discussion, moderate the panel discussion session. So though you are a panelist, but still I'm requesting you to moderate the panel as well. And I'll also pitch in with you at the time of question answer. So it's all stage is yours, Dr. Pal, Professor S.K. Pal, and Dr. Sinha. Over to Dr. Arpan Pal. Please moderate the session. And the three eminent speakers from industry who is working on the field of academia as well. On the other hand, from the academics who is working in collaboration with industry, and Dr. Sinha, who did IIM and PhD, also working for research and academic collaboration. So stage is yours. Over to Dr. Arpan Pal.
Okay, thanks, Dhanusham. Am I audible?
Yes, you are.
Okay.
Yes, you are.
So I think over the next, maybe first what we'll do, maybe next 30, 40, 35 minutes, we'll just spend, maybe I'll ask Professor Shurjapal and then Dr. Sinha and then myself also. We may spend some 10, 15 minutes each to give some perspective, like from the academic perspective and also from the industry perspective, what we see as the application, the challenges of IoT in manufacturing. And maybe after that, we'll open it up as a more interactive question and answer session. So I think, Dhanusham, that should be fine, no?
Yes, this is perfect, Arpan.
So then I'll ask Professor Shurjapal to start to his views, maybe for 15 minutes.
Yeah, okay. So let me just share the slides and all. So before I yeah, is the screen visible now?
Yes, sir, it is visible.
Yes, sir.
Yeah, so wish you all a very happy Holi, first of all. And it's a Sunday evening, we are all sitting.
Same to you.
Yeah, I was listening to what Mr. Pradeep Mishra has told, the very wonderful lecture on the different types of the devices and the softwares. So it was a very good piece of information, and some of the the units which we are using for the monitoring and the control in various domains of the advanced manufacturing, that I'll explain this particular discussion. I'll try to restrict within maximum 15 minutes. That's what I was told. So what we understand when we talk about this IoT, Internet of Things, or the Industry 4.0, or we can call it as the Industrial Internet of Things, IoT, in different names. If we look into the journey of manufacturing, because the IoT application in manufacturing is immense. So we need to understand that how the flow of the manufacturing has taken place over the years, starting from its mechanization to electrification to robotization, and today we are standing at the era of Industry 4.0 in the network Internet of Things. Everywhere, every step when we consider, we'll find that the industry's perspective is that to reduce the cost of the product, to increase the productivity, and the product should be having very high precision so that the quality can be ensured. So at each and every step, that is the concern, and that these concerns is driving the manufacturing sectors to come up with the innovations. So when you talk about this Industry 4.0 or the Industrial Internet of Things, we all know that these are the units which are mainly the concerning, starting from the system integration, cyber security, additive manufacturing, robotics, augmented reality, Internet of Things, simulation, big data, cyber physical systems, and cloud computing. All these modules are under the umbrella of the Industry 4.0. Purpose is that for the objectives that cost has to be reduced, productivity has to be increased, product should come up with a high precision so that the ultimate quality can be ensured. Now, out of when we start the implementing these concepts in the manufacturing, we face a lot of the difficulties. So today we have just started our journey. That is the 2014. We have started our journey on the Industry 4.0. We are still struggling. And the major the industries, specifically the MSMEs, they do not have the concept or the complete visibility or the clarity in terms of these the modules, how these modules can be leveraged into their respective the industrial practice so that they can fulfill those 4 objectives. So when you talk about this manufacturing, we mostly talk about the robotizations of the application of the robotics, because that is directly concerned to the automation perspective. If we look into the the application of these robotics, you see the country-wise we are we're at the bottom in terms of the utilizations of the robots in the industrial the sector. So this is a graph where it is showing that the per 10,000 employees, how many robots are used sometimes in 2016. So India, the number is 3. That means 3 robots per 10,000 workers or the employees in an industry. Whereas the South Korea, if you look into this, that's 631. Now, whatever may be the reason, like India, we do have a large population, that could be one of the logic and all. Whatever may be the reason, that automation is more adopted in those countries like South Korea, Singapore, Germany, Japan, and others, as compared to the India. As soon as we start utilizing the robots, we are moving from the domain like from the hard limited flexibility to this the high flexibility, high productivity, the productions. So the quality would be better and better in the later stages and all. So as of now, in most of the cases, wherever the robotics are used, it is most of the let's say the highly programmed, either if it is a manual mode or it's a highly programmed situation. That means it is programmed to do a repetitive job. So it is not accustomed to tackle the dynamic situations. That means we can say that no intelligence is involved. Even though no human intervention, but the intelligence is very limited in terms of the activity or the program that has been the mandated or given to the robot, even though it is producing a very high productivity. So, but because of these dynamic the situations, we need to understand that how these, these robots which are in place in the industry, how they can be collaborative with the human being, so that the flexible system can come up. Robots can operate in the dynamic, situation, so that it can come up with a smart product. So even though the robots are in place, but our actual vision under the Industry 4.0 or Industrial Internet of Things is that the collaborative nature of the robots must be there in the software. That means robot-human interaction has to be there to bring the flexibility. So I'm giving an example of this, the job, this work, that how can a robot, avoid the dynamic obstacle. So if a robot is, asked to, pick up the job from one place and then move it to the other place, depending on the industrial need, and during its path, if some obstacle comes up, then how that can be, solved. So people are working on that. In fact, my group is also working in this, this field, and where I'll give you. Where I'll show you that, the small video, one car has to move from one place to the other place, and during its movement, all on a sudden the obstacles are coming up. So we have written a code how to avoid these obstacles, and at the same time the ultimate goal has to be made in a very, should be done in a shorter, the path. So these sort of situations would be very much needed when we would like to place the robots to work in a, the dynamic situation, or the robots have to work with the human being. If the operator comes up, then robot has to find out that whether the operator is obstructing obstructing my path or not. If it is, then I need to find out an optimized, the shortest, the route. So this is an example of which we are planning to do implement in the robotic facility. We have successfully done the simulation. So the IoT, the applications in manufacturing, we understand in these four aspects mainly. If you look into carefully these four aspects, you will get to know that majority of the manufacturing applications are coming up, which are really concerned today or bothering us, are falling on these four categories. That is the real-time product quality analysis. Dr. Mishra has told that, the image processing plays an important role in identifying the product quality in the shop floor. Similarly, that we need to understand that what is the health of the equipment which is producing a job, how long it can serve. So that means the digital version of the health, which you call it the digital twin, that has to be in place so that we can get to know how long the machine will work. Not only that, if a machine is working and it is quality, it is suffering from some sort of, the problem, then the parameters which are, the operating parameters should also need to be optimized depending on the instant health of the machine itself. So that means again the dynamic nature is coming into place. There are a lot of applications where the remote, the operations are, they're coming into picture. Like the operator is sitting at one place, the machine is at the other place. The operator cannot go to, beside the machine for some reasons or the other. So how can the machine be operated? And at the same time, the safety in terms of the operator, safety in terms of the machine. So all these, the factors are to be studied through the implementations of each and every, the needed modules of the Industry 4.0 that I have mentioned. So if we look into this, the sectors one by one, real time, the product quality is the first thing. If we, I'm giving an example of the the manufacturing process, which is the car casting process, which is the age-old technique in the most primitive manufacturing process. So previously it was purely the manual. That means melting of the material and then pouring into the mold and then taking out of the product out of this mold and all. Then over these years, just to fulfill those four objectives I mentioned, people, they came up with a different, the concepts. Now, up to the, the first 5 concepts, if you look into this, that is more of the mechanization. like the manual to flexible to semi-automatic to automatic to flexible automatic. But the last two, the steps or the bulleted points, people are thinking about how the dynamic situations can be tackled. So first fives are purely the program situation, automated situation. Next one also for the automation, but here to tackle mostly the dynamic situations in the software. So I'm giving an example, like in a the cladding process. If you can measure the glow of the molten pool, if you can capture this image, then that the characteristics of that image can be very easily used to monitor what is the cladding quality. So the middle picture is without any monitoring, the aspects. But the last picture is showing that if you can control this, if you can characterize this the image, then you can control the laser parameters to come up with the better the mold. So different types of the defects can also be very easily identified by the imaging. As Dr. Mishra has rightly mentioned that image processing has huge, immense applications, and still we need to travel a lot of long distance to ultimately come up with the product or the software or the product which can be readily used in the industry. Another example is that for the machine vision systems, the quality inspections. The previous one is the real-time process control, and this is, let's say, to avoid the rejection of the product at the quality stage. Most of the industries, so for them it's very difficult, to judge each and every product, in the shop floor, on the real time. So here we have, came up with the image processing based solutions which can be very easily implemented to come up with the real-time inspections so that it can avoid the rejections of the product and also ensure the quality. Yeah, another, I'm giving quite a few examples where you can find out how potential the image processing technique is for the quality inspections. Now the circuit board or the motherboard, there are a lot of the components of different numbers and different sizes and different types. If something happens, so it's very difficult for the for a person to even for the experts to actually pinpoint what is that fault. Similarly, the image processing, I'm giving an example for automobiles, how to check the distance between the two electrodes in the spark plug. So this is an example which we have done in case of the wheel beam inspections for the automobile. We captured the image by using a webcam, low-cost device, thinking in the manufacturing, small and medium enterprises applications. We captured that image and by low-cost camera, and then we applied these AI-based techniques. So after several iterations, we came up with the enhanced quality, which is almost at par with the image taken by the good quality camera. So the lower the image is taken by good quality camera. So if you see this thing, so how much potential this artificial intelligence is having, which can augment the image quality, and then finally it helps in processing. And finally, it is giving the product quality with 99% accuracy. We have also applied the signal processing. Dr. Mishra has rightly told that people have used this sort of techniques previously, but not in the name of the IoT. I fully agree with Dr. Mishra, because the crux of the IoT is basically the processing of the signal or processing of the the image. So if you can rightly capture these the sensors the data, and if you can process it, we can rightly correlate with the product quality. So this is the lower picture is your the actual process, welding process, and the upper one is that the feature of the signal. Here it is clearly showing that how how the good quality weld is getting differentiated from the defective weld through signal processing in the real time. This is also another example of this image processing. You can control, you not only monitor, monitoring is one aspect. So as I mentioned, the control has to be also looked into. So we have captured that image by camera and then processed that image in real time, and we came up with a defect. Well, this has also been filed as a the patent. I'm giving an example which you have done with the Tata Consultancy Services with the team of the Dr. Pal Mishra. So here what we have done is that we have used the friction stir welding. The process, it's a solid state joining the process. In this case, we have engaged large number of the sensors to collect the information about the process, and we process those sensors data in the edge device. If everything is fine, then the process goes as it is. If something is, the signal is getting deviated, we are sending it to the cloud for taking a decision through the machine learning, so that the feedback goes to the machine to change its parameter, and ultimately the defect-free weld should come out.
So
Here
Professor
also,
Paul, sorry to interrupt. So maybe in 1 or 2 minutes, if you wind up. Okay.
So this is the example, like the defect-free, the weld quality, the detection, that we have also filed a patent with the Tata Consultancy Services. Similarly, for the predictive maintenance and health monitoring. So in a furnace, this has been applied in the Tata Metallics. Our faculty colleagues have done with the collaboration with Dr. Sinha and other the researchers of Tata Group. So they have came up with the furnace, the health, that is the different motors used in the furnace, what is the level of vibration, how it is real time affecting the process quality. That has also been monitored, and it has been used in the Tata Metallics just for its acceptance. Similarly, the remote, as I've mentioned, that there are a lot of applications where in manufacturing where the remote operations are there. So digital twin is one such applications where the health has to be monitored, the remotely. Health of the different components of the machines. We gather the signal from the different, the components, analyze those signals in the real time, and we come up with a predictive plan and all. Similarly, for the safety analysis, as I mentioned, the safety not only for the machines, machine-to-machine interactions, safety also for the operators present in the shop floor. So the augmented reality and virtual reality are coming in a big way, for the service sectors and all. As I'd like to conclude this, my initial, the portion of the talk, that futuristic application, where manufacturing is aiming to. It is not only for the the remote application. It is also that how the thoughts of the operator can also be analyzed remotely, so that the thoughts of the operator can be used as the input signal to the robots for performing a defect-free the product. So now, out of all these things, whatever I have mentioned, when you talk about this Internet of Things. Things means that devices, so different, the types of devices would be needed in the shop floor to come up with a complete Industry 4.0 solutions. And, so the machine-to-machine interaction, so large number of data would need to be gathered and captured and analyzed. And for that, we must, have the faster, the communication. So the deployment of the 5G or the higher version of the network as and when we have coming out, so that has to be deployed for better, for low latency, the more security and all. So thank you. So it is. I'd like to conclude that Industry 4.0 is no more an option. It has become a the mandate, and the industry must make use of that the concepts. The sooner the better. Thank you.
Thank you, Professor Pal. And I think it's a very nice and insightful journey of the manufacturing, how we are actually applying IoT and Industry 4.0. So I think we'll come back to the questions later. So I would ask Dr. Purnendu Sinha now to just maybe use 15 minutes to just give his views. Dr. Sinha? Yeah. So you're on mute, I think.
Yeah, thank you, Dr. Pal.
Thank you.
Let me just share my screen and please confirm if you are able to see it. Can you see my screen? Is it visible?
Yeah, it
Yes,
is
yes,
visible.
yes, Shinna, you can.
And my camera is also on because I can't see myself. That's why I'm asking.
No, your camera is not on. I think that's okay. Maybe if it is.
Okay.
Yeah.
Okay. So thank you, first of all, and good afternoon, everyone, and good morning, good evening to others logging in from other locations. Building up on what Pradeep and Professor Pal have already built, what I've tried to put together is a general notion of how factories of the future would look like, and give you some case studies from our own Tata Group on how they have become the factories of the future. And I believe there was a question also from audience, so maybe it will address some of those points. So if you look at any factory, so there are typically these 10 dimensions. And the first one is that the leadership aspect is very, very important. What I mean by that is that there has to be a collective might and behavior of the leadership to inspire, support, and accelerate the digital transformation across the plant, right? That is very much important. It has to be top driven if you want to make a difference. So that is the first dimension. The second dimension is that there has to be a well-defined structure, policy, and plan to roll out the digital strategy. So the entire organization has to align, not just the four walls of the factory shop floor, but the IT department, the procurement department, the supply, interface with the logistics and other things. So entire aspect needs to come into the picture. And as you have been hearing about IoT, so basically what IoT is doing is giving you the data, right? And one of the important aspect in any factory shop floor is to be able to minimize the maintenance and operating cost. And you would like to do it very much like based on the data, and it has to be a data driven maintenance, which looks at the different aspects of health of equipment, and also the historical events of when earlier failures were taken place and what sort of a maintenance was done. The next important thing is that then you have to ensure that the data, here Pradeep talk about the edge computing. What it essentially means is that the machine which is experiencing some sort of malfunctioning, there has to be a real-time availability of data. Certain decisions need to be taken close to the equipment rather than sending the data to cloud and bringing the data back. You may not have that much of a time to handle that sort of a situation. The next one is that the material flow is very, very important, right? You have to ensure that we call it 4Ms: man, machine, methods, and material, which needs to be handled in a very coherent and synchronized fashion, that the time wastage, material wastage, the idle time of the machine. All these things are avoided. The next is that you have to ensure that you're putting your system somewhat on the network, whether it's safeguarded. That means you have a firewall which is protecting your equipment from outside access. However, you need to make sure that uh, the malicious intent of employees or a worker inside the plant should not also compromise the integrity of the machine, and some sort of a cybersecurity aspect needs to be also covered. The beauty of factories of future is that you would like to have a complete 360-degree view of the entire value chain. If you are in an automotive industry, then you have to look at the value chain of procuring the raw material to actually assembling and getting all the parts from different suppliers and putting together your car, and then actually shipping it out from your factory floors to the dealers, and then eventually delivering to customer, right? So the entire gamut of thing has to be captured. No more the siloed functions will work. It has to be all integrated properly. The quality is going to be paramount as we are going to be globally competitive in manufacturing sector, at least from India. It is very, very important that the quality becomes world class. And the lot of companies have what they call WCQ initiative, world class quality initiatives. And basically what you have to do is you have to ensure that you have the sensors, whether it's a vision based sensors like Professor Pal was talking about, and also the processing software which will allow you to look at the data and inspect quality of parts produced in real time, and allow you to manage if there are any deviation in quality by controlling those aspects. The workforce need to be trained. It's no longer that you have set up a world-class factory, but the people who are operating it are not at all trained to know how to use robots, how to program robots, how to use cobots, how to use a SCADA DCS system. A lot of aspects of those things are there. And the finally is that that you have to have the hardware infrastructure which will allow you to minimize the human intervention, and that is basically very much need of the hour because of the COVID situation. So based on that description of what the factories of future would look like, World Economic Forum, the fourth Indian industrial revolution, what they did, they started in 2019 to identify factories across the globe and evaluated them against certain criterias. And the criterias included that how much of a digital technology penetration has gone into the factory, what is the level of scale they have, what is the level of impact they have made, what sort of workforce training infrastructure they have set up, and things of that nature. And now there are 69 of them, but this slide shows about 44. This is the last year, but this March they have included a few more lighthouse. So there are 69 of them. Initially it started with 25, then 44. And you will be pleased to hear that 3 Tata companies, and they all 3 from Tata Steel Group, they are the lighthouse factory. 2 from India, Tata Steel Kalinganagar, which became lighthouse factory last year. And this year in March, Tata Steel Jamshedpur became the lighthouse factory. And the first in the group of original lighthouse factory, we had Tata Steel Europe qualified as lighthouse factory. And then you can see a bunch of others. The only distinction in the light blue and the dark blue is the light blue ones are they are looking at end-to-end visibility of it. That means they're actually looking at 360-degree view of the industry. This chart basically tells you that what are the different business KPIs which these lighthouse factories have explored. And so the chart on the right hand side, the graph which is showing, is basically showing that say if I look at overall equipment efficiency increase, OE increase, there are companies among the 44, if suppose 10 of them have reported that the KPIs, then you see that from 2 to 50% range has been there in terms of improvement. Say for example, factory output increase has shown from 10 to 200%, right? That's an outlier. But if you look at basically the clustering which have been done in the purple ellipses are the major clusters, which shows that where majority of the benefits companies have gained. So just to give you an idea of Tata Steel Europe, what they did, they decided early in their digital transformation map or roadmap, if you want to call it, that they defined that how end-to-end the scale would be supported by senior management, and very clear-cut strategy to improve the EBITDA margin. And there was a very stiff target which we are taking. Tata Steel Europe qualified as lighthouse factory among many. The one of the key aspect was that they were able to decide early on that it is better to train our own employees in data analytics and machine learning rather than relying on external partners. And they set up a digital academy which trained now more than 500 employees in that. And another important thing which they have is what they call it as a digital translator. This is very, very critical and very unique concept, which has now being adopted by many industries and many companies now, is that you have to have a business person be part of the team who understands what the business problem is, what that data actually means, right? And once the analytics team has done the analysis, what that data analytics interpretation means from a business language point of view, right? And how would somebody take that analytics output into the business? Like, it's no longer beneficial to just show something based on analytics unless and until business adopts it and benefits from it. And in the table below, you will see that based on advanced analytics, based image recognition, they were able to minimize 50% cost of yield losses, and few other KPIs, and the benefits have been mentioned over there. If you look at Kalinganagar, the similar kind of a thing, they also looked at that it was a greenfield project. That means it was starting from scratch, and Kalinganagar management wanted to ensure that from the word go, the factory will be set up with complete digital maturity in mind, and they wanted to make sure that the factory gets up to the full production for the first phase itself, at least in the minimum record time which was anticipated. And you see that the time to market was improved by 50%. They as I mentioned, that they had the digital strategy to begin with. They instrumented most of the critical machines. They started collected the data over time. They built the predictive analytics model, and today some 50,000 plus machines are maintained using predictive analytics. And similarly, they also went ahead and started skilling their own workforce, in terms of digital technology. One thing to highlight, there are senior management who are part of this training. Of course, there are different types of training given to them to appreciate, digital technologies and what benefits they give. Then the middle management, and then the workforce, which actually, gets onto the hands-on task of doing modeling and data engineering and other things. And similarly, you will see also here, how Tata Steel Kalinganagar has benefited for different KPIs. Say, for example, they minimized the quality variability by able to control the input parameters of raw material which was going into making of steel, right? So that is a very, very important aspect. And we worked on similar problem with Tata Steel and Jamshedpur, and I think they must have emulated the more or less the same also at Tata Steel Jamshedpur thing.
Purnendu,
So,
just sorry to interrupt, maybe another minute or so.
Yeah, so
last slide.
this is the last slide.
Okay.
So basically, the vision and roadmap is very, very important for digital transformation journey. You need to identify the business KPIs which will create big impact, and then you have to do value assessment on all these different KPIs to see which are the low hanging fruit, which will have the early wins, which can convince the management that we can move ahead early. Then you have to create, rather than proof of concept, you have to create proof of value pilots, right? No longer the proof of concept is desired. You have to show the value out of your prototypes and pilots which you do. And scaling the use case, that means at one location, at least 50 to 100 use cases must have been deployed and implemented and looked at. So this is what I had to present. So I'll stop sharing, and I hope I'm not overrunning.
No. Thank you, Purnendu. Naturally, it was very insightful presentation, and I'm sure the audience has quite a few questions. So we'll come back to that. So before that, I will just maybe take another 10 minutes to present what I would should tell that I think what you already have seen. I think Pradeep has given a whole kind of a complete spectrum of IoT application. Professor Shurjopal has given a very nice context of how it is getting applied in manufacturing, and Purnendu has brought in the what you call as the industry view of it. So what I thought I'll just end with it is give a view of, because there's quite a bit of faculty and students are there, and I'm being from the industrial research. What are the practical research problems that we think that the world should work on and we should work on? And I'll just try to give a glimpse of that in next 10 minutes before we will open this up for the question. Okay, question answers. So let me just share my screen. Is my screen visible?
Yes, your screen is visible.
Okay, thank you. So I'll just start with that's what I was telling that. So what are the technology challenges that are there? So I have kind of listed a few things. So I think whatever I'm going to tell, I'm not going to give us. Most of them are kind of will refer back to what Pradeep, Professor Shurjopal, or what Purnendu has actually told. So those applications, those use cases, practical problems that are there. One is actually we don't know what you are talking that we are kind of taking the sensors as a default for IoT in this kind of industrial system. But how easy is it to sensorize those? And are there any difficulties? So we are talking about multiple sensors. So how easy or difficult is to fuse those sensors data? And we're talking about age. So what are the issues of agification? And we are talking about AI. So what are the practical practice? What are the practical issues of AI that we should actually look into? So I'll just kind of try to spend time on those kind of things. And I'll talk about a few technologies on unobtrusive sensing, device edge computing, multi-sensor fusion, and what we call as robust AI. So and trustworthy AI. So I'll just try to look at that as a view. So one part of the thing that if you see in most of the industry systems, ultimately, whatever we talk about, what we are talking about is that we talk about the either asset uptime or is happening. So either we are talking about the asset uptime or we are basically talking about improving the yield quality. Effectively, that's what it is. But one reality that is there, and we have to kind of look at this, is 80% of the plant equipment in the world, I'm not talking about India, but all the world, this figure is there. In the process industry are more than 25-year-old, which doesn't have any sensor on them. So how do we sensorize them is a big problem that we have to look into. And so because many times these legacy machines don't give this sensor data, is very difficult to give. Retrofitting sensors is also not easy. And so how do we actually go about this? So one concept that we try to bring in, that can we sense from away? So like human eyes, ears, and nose, can we have a vision which is from away? And I think that's why we saw so many use cases that is coming from camera, which is kind of an unobtrusive sensor, which is easily deployable and many other things. So conceptually, what we mean by that is that it is not only about the camera. I don't know what is happening, why the screens are moving that way. Anyway, but the camera, around the camera, so it can be radar, it can be sound, it can be photoacoustic, it can be polarization. So many other things can actually come together in this sensing means, which kind of tries to actually understand that condition of that material or the machine without actually touching it. So this is an extremely important thing that actually people have to work on, because many of the industrial problem has to be solved in this way. Even if you want to kind of install sensors on the robots, they have to be this kind of unobtrusive sensors. So this is one thing that we have to kind of keep in mind, that how do we really go about and deploy this. So this is one, I would call, set of problems that are going to come in, which is kind of, you can think of that, can we actually create a soft sensor using all these kind of physical transducers, which are beyond the typical sensor that are there, which is kind of looking at from away, and but still trying to understand the condition. So this is one part. The second part, I think we have a lot of very detailed and discussion on the edge. So I'm not going to go into details of it, but objective, as we know, that it is reducing the latency, preserving the privacy, improving the reliability, and reducing the cost becomes the most important thing. And how do we go about it? And we have talked about this IoT, robotics, and AR, VR, XR application. But what I would kind of give a kind of a takeaway from here is that if you see the two technologies, inferencing at the edge and the learning at the edge, the things that are becoming very hot or important is that so AI model compression and AI model partitioning and acceleration. How do we actually do it in a very generalized way is a challenge. And how do we do it? And learning at edge, obviously the incremental learning and the distributed federated learning are actually because you have to learn as we kind of operate. And that is not an easy thing to do in a thing. So these two things are very important. And the third thing that is coming up, and it is a forum called is tinyml.org. So this concept called tiny edge or tinyml is coming up, and I think we should look at it because it is of extremely tiny edge devices with a sub 1 megabyte of memory is a kind of thing. Very difficult to fit any existing deep learning models in this, but that is the next requirement. So and how do we do this? So this challenge is there. So I'm just looking at the challenge, not about the solutions at this point. And as I told, multi-sensor fusion, this already Professor Shujapal talked about it, but how exactly, you can use this multi-sensor fusion? There are very interesting deep learning methods that are there now, which can be used along with the representative learning and other kind of things. So where you can actually fuse multiple sensors together without really handcrafting anything from them. And the system can automatically learn which features from which sensors are actually important. That is what we call as a representation. And this becomes a very important aspect of the future Industry 4.0 AI-based application. So we are actually working on that part. Now I'll talk about a couple of use cases. Like one use case, I think there was a question on the Tata Steel. So this is the Tata Steel use case. What you see is a picture, what we worked on is a coal conveyor belt where the coal actually gets fed into the blast furnace. And that actually, the coal actually has a lot of foreign objects. Like you can see this example, but a lot of foreign objects, wood and concrete and everything is there. So if each of these goes to the crusher or the furnace, actually there's a big issue that from the quality or the maintenance perspective pops up. How do you detect? And the problem is most of them will be covered with black coal dust. So all are black. So most of the time, a typical only a camera cannot pick it up. So, and that is what actually comes. That's why so we solved this, that unobtrusive sense by actually fusing the normal camera with the polarization camera. So the polarization actually can give a lot of information about the material that is comes from the physics of it, you know that. So if we could fuse the polarization camera with the RGB camera, we could actually get this detection in pretty good. So this pilot was already done with a very, and it is a very interesting edge use case also, because there is a high frame rate. You know that, think of this conveyor belt is moving and you have to detect this, and if something you detect, you have to grab that and take it out. And it has to happen in seconds. So it is a very real-time requirement. So processing has to be done in edge, and the algorithm also, you can see that you can take as everything. So there is a fusion here between the polarization and the RGB camera. There is edge computing here. All together, you could actually give a working system here. Second example, again, one of the largest car manufacturers in the world, they're very finicky about their quality of the car seats. So it is a large car seat manufacturer. So car seat, if there's a very small wrinkle, they want to reject it in the assembly line itself. So it is again, it is a vision problem. But the problem is actually, if you want to do it in an assembly line, we could actually build it in offline. We could build a very high accuracy wrinkle detection system using the camera data. But the challenge was that how do we actually deploy it in the edge? Because that this thing was in a, I think, tens of GB, the memory, that whatever we build as AI model. How do I fit it into that? Even if it's not 1 MB, but hundreds of MB, if I want to bring it down, how do I do it? So there's a big challenge there. And so we actually solved, and we're still working with the customer to do that. The third last part is this thing that what we call as this robust and practical AI is the other problem, that we kind of assume that the data is already there with you and labeled data is available. But in reality, there is a cost to the data annotation. It's not easy to get labeled data. So crowdsourcing of data annotation, training with small data, unsupervised way or imitation way. So these are actually the future research challenges without which you cannot practically deploy. And how do we augment? Basically, there is a lot of knowledge in the factory with the operators and other. How do we actually augment this or knowledge into the deep learning models? And how do we actually use, Pradeep talked about this, how do you use pre-trained model and use transfer learning to actually do scale deployment? Because you cannot go and tell that every factory I will collect data for 6 months to learn my model. It's not acceptable. So how do you do it? And future concern, obviously, this explainable AI, liability, trust, empathy, and ethics are important. So I'll just quickly touch upon it before I close. So one part is this trustworthy AI, because you know that all AI-driven machines are not reliably predictable. Like I've given this example of this remote control, which is a very predictable machine. We use it every day and out. Every time it behaves in the same way. But you know, whenever you talk about AI results, you talk at 95%, 98%, 99% accuracy. So that means every 100 times, 2 times, 5 times, or 1 time it will fail. So the challenge is, how do we trust machines that are actually not predictable? We are not used to those. No? I don't think if I tell you your car every 100 times, every once, 1 or 2 times, 100 times, when you press your accelerator, it will break, and vice versa. You will not use that car. You will not trust that machine. So how do we do that? So there's a big problem here. The second problem is that comes from the idea, if there's AI is making mistakes, it will make mistakes or it will give errors, whatever the 99%, 99.9, and whatever be it. Who takes the liability of those decisions? Because AI for controlling machines or driving autonomous vehicles or predicting machine health or monitoring worker safety, each of these use cases we have discussed today. These are different from detecting friends' faces on your Facebook or understanding a voice command on Alexa. Here, error can lead to very critical problems. Factory may shut down. There can be deaths. There can be injuries. So who takes this liability? So there's a big challenge to really, and there's an idea that people are telling the liability has to be the humans in loop. They should take it, and AI should be helping hand to them. But in order to do that, then AI has to become interpretable and explainable to that human being who has to take the liability of the decision. How do we do it? And how about the ethics and the bias that comes in the training of the data? And so how do we actually, these are all open questions I think we should actually try to answer before we really can think about this to be a really deployable and I would call practical systems which can scale in this kind of way. So there are still a long way to go. And with that, I will end and stop sharing also. I think I finished in, so maybe we can now open this up for the questions. Anushan?
Yes, Pradeep, there's Orban, that's all up to you. I mean, if you think that presentation over, so
yeah, my presentation is over.
Questions now.
So I think because we have some 10 minutes, so I had a couple of questions to ask Professor Pal and Dr. Sena also, but I think first let us open this up to the audience and see what the questions the audience have.
Yeah,
for all of us. Yeah. Anybody?
Request participants to please unmute yourself and ask questions to the panelists.
I want to ask what is the factory of the future. Hello, Mr.
Yes.
Dr. Sinha has presented the factory of future. Is excellent view. In fact, in my life, I have seen first time such a comprehensive view. Sir, what about the pupils part? No, this is technology you have shown. You know, whether you like to, whether the, I'm sure that everywhere the pupil part is embedded. But it cannot be the factory of future should not have the component of the pupil, the skills, competencies.
So very valid point. I think there is an echo. Okay, yeah. So very valid point, and I think I touched upon that aspect. As part of the 10 dimensions, that workforce skilling is one of the important dimension. And while giving you examples from Tata Steel as lighthouse factory, I mentioned that Tata Steel, in general, as a group, they set up, digital academy to train their workforce in machine learning, AI, data engineering, and it is very much a part and parcel of skilling of workforce. The other thing which you would maybe Professor Pal can elaborate further. Any one of the center of excellence which have been set up by Government of India under Samarth Udyog initiative, all these centers are supposed to offer training programs, awareness sessions for college students, for research scholar and MSMEs. So it's very much driven agenda by industry to train people. If you have any specific question, I may be able to address that from skilling, but that's my general comment.
You know, the framework for digital transformation,
yes,
which is sometime that MIT has researched on. And,
yes.
Workers' enablement become the very important component of that. They talk about the customer experience and operation optimization, business model change. And the workers' enablement now, recently 2 months back, only a new framework, a revised framework has been announced. And they have shown the workers' enablement as a very key component of the digital transformation. So here the question of not only skilling comes, there are so many other factors now, because the culture, so many aspects now. So when we talk about the factory of the future, probably, that component also become a little bit, that component also become equally important. That, the ecosystem which you have shown, like digital organization, maybe you will like to include that as a part of digital organizations.
Yeah, so just to add, maybe if you look at, Ministry of Skills, which has promoted skill drives in India, and there is an institute called Tata Indian Institute of Skills, which have been set up in Ahmedabad and Bombay. There, basically, the ITI graduates who are diploma holders and they are working in factory shop floors, they are getting trained on advanced machines, advanced CNC machines, programmability of robots, using of cobots. So companies are like Festo, for example, has contributed there in setting up these institutes. So there are many different initiatives in India. I think we have started the journey. It will take about a year or so to see the results, but I think we have started that.
Thanks, Purnendu. And any other question from other?
I have one question to Professor. Hello.
Hello.
You have mentioned about Professor Pal in your slide that you are working on collision avoidance of vehicles and all these things. So can you highlight on it about the collision avoidance process in the industry, what you are following for IoT applications, especially for cars and UAVs?
Hello, can we ask everybody to mute themselves, please? Yeah. So yes, Professor Paul, please.
Yeah. So you have mentioned about the applications of the obstacle avoidance. So what we have done, I mean, planning to do is that, in a robotic operation, specifically for thinking in terms of the cobot applications, because the cobot has to work, along with the human beings. So in the presence of the human being. So while executing the job, in the obstacle comes up in its way. So how to, bypass that obstacle and reach to the final goal. So for that we have the simulated the movement of the car from one station to the other stations, and now we are planning to implement into the robotic facility for the job, the material handling, basically picking up the job from the conveyor belt from one the one is coming up and then placing it somewhere. So we are trying to implement that right at this stage.
So are you considering the PSO kind of particle swarm optimization kind of algorithm?
When we are applying the machine learning, the deep learning method, machine learning methods, and the deep learning methods for that, the finding out the optimum path and all.
So I can answer that actually. So many in this kind of scenarios now, the deep reinforcement learning is actually becoming a very good thing to use. In many of this, I would call the optimization problems that you have to for the path planning and avoidance of kind of thing. It is a very good thing if you have data. That is a question mark. If you have data, then deep reinforcement learning can actually solve a lot of problems.
So are you considering three-dimensional obstacles, means from the stop from the side like this,
No, right now it's because three-dimensional pose is a complex thing, because the orientation of the job in the jet plane also that comes up will come up. Right at this moment, it's on the XY plane. So if the robot has to move at a certain height, let's say from this position to that position. Okay, so when it is moving, so in that path, any obstacle comes up, and then how it is going to get avoided. That's why we have taken up the cart problem.
Thank you. So any other questions?
The challenge is same. Is the challenge same in case of underwater vehicles? Means underwater UAV, underwater things, that.
No, but in case of the underwater, the problems again, the three-dimensional aspects may come into picture in different planes. The obstacle may have in the different planes and all. So right now it's a car moving in the XY plane and all. In a definite path, it's moving. So that is not any jump or the movement of the change of the height of the car at different locations and all. So we are neglecting the third dimension at this moment. But whenever the underwater, the vehicle underwater, the movement you think of, so there may be the obstacle at the different, that different depth of the water itself. So anyway, even for the obstacle avoidance, also the three-dimensional aspect will come up. But the problem which Dr. Arpan Bala has mentioned, that even though the technologies are there, devices are there, sometimes the gathering the data from the real world situation is a real that difficulty. So that's why since we have the simulated it absolutely, the simulation is absolutely fine. Now the implementation stage comes up. And so there we are starting considering a situation that it is it is in the XY plane. And then when we get success of that, then we'll definitely think for the other dimensions. Okay. We are also doing a lot of work on the Dr. Paul has mentioned that when the job is moving on the conveyor belt, so different types of the cameras are put in and then images are captured. So we are also working on that. If the job is the coming up in a different at the different location and also the different orientation. Again, it's an XY plane. Okay, so then how the robot will identify what is the location of the job, and it will accordingly, because it has to change its the axis as well, so that it can grip the job. So those, the coding programming is done. Programming is absolutely fine. Now we are facing difficulty in the actual calibration and implementation. So integration, these codes you'll find a lot of publications, a lot of things, but when you are actual going for the industrial application, there is the difficulty because the data has to be transferred in the real time. And Dr. Pal has mentioned that why the people are thinking of the robust AI or the realistic AI or something like that. So because we are applying and we are gathering, capturing the data, but we are not sure whether it is giving the very good correlation or not. How fast the data has to be transmitted, whether it is actually it can depict the real world situation. Because the conveyor belt job is moving at a constant speed. Within that speed only, the robot has to capture the image of the job and its the pose, its orientation, not only in the XY plane and also in the X plane. And if something happens, like the job comes up in a different types of the job, so the robot has to again change its the gripper, change its positions, and then capture. And then we have successfully done, all coding is done, but the problem is that implementation. So there lies the real the challenge. So they are nice of scholars are working.
Thank you, sir. Thank you very much.
Thank you. Any other question from anybody?
Yes, I have one question. That
Yes.
how edge computing align with 5G technology, 5G communication technology?
So let me take that answer. So I think so effectively, if you see, edge computing and 5G are going to become what I would call as a symbiotic technologies or complementary technologies, because edge effectively what it tries to do is to reduce the bandwidth. Is one of the goals that Pradeep was talking about it. One of the goal is to actually see how much of that I can do in the edge of the network, and I need not offload it and load my network. On the other hand, 5G gives you excellent, not only the bandwidth, but also excellent latency of the network, which was not there in the 4G. So now if I want to do some real-time computations, because of the real-time nature of my inferencing, I can actually offload it back to the edge and still cloud and still do it. So effectively, if I now take it together, you can get best of the both of worlds. Because if I try to do everything in the edge, I am limited with the compute capacity. If I am going to the cloud, I was kind of earlier here with the latency of the network, unreliable the network. So if 5G and edge comes together, I can get best of both the worlds. So that is the goal, and that is the, I would call a holistic goal. Let's see how it pans out. So that is what 5G is supposed to give you. Very low latency, and I still have that kind of edge and cloud together. That's what we'll do.
Yeah, I'll just add a bit to that. There is another related thing which has taken off these days. It's called mobile edge computing. And what that involves is setting up of computing environments by telcos at the edge of their telco network, right? So they are setting up computational facilities and storage, networking at what is to be called the central offices of the telecom network, which means it's right at the edge of the mobile network. So instead of transporting the data completely to the backend, to the core, some computation can happen at the telco edge, right? And these mobile devices or sensors which have 5G connectivity, therefore have a very low latency connection to the central office or telco edge. Now, lots of these things have already come up, not in India, but in other countries. And many of the cloud providers like Amazon and Azure, they are collaborating with the telcos like Verizon, and they have set up the telco edge. where the cloud computing facilities are now being offered from the telco edge. So that is another related trend here.
Thanks, Pratik. Any other questions?
Thanks. I understand that it creates a huge interest, but because of time constraint, we can take at most one question. It's already almost 10 minutes is over. So at most one question, if anyone have. Otherwise, I know that lots of questions are in your mind because of this outstanding session by three panelists and one speaker. So please, one more question only. So Arpanda, you had one question for Professor Pal, so you can, or Dr.
Yeah, I think
Sinha.
Professor,
So
Professor Pal, yeah. I had one question, I think, Professor Pal more or less answered that question. So I think it's a more generic question, as a Pratik may also talk about this. So, always this, when we actually talking about this IoTification or edgeification of these systems, so it actually costs. There's a big capital investment of doing this. So when you see practical deployments, how do you actually justify the ROI in the beginning of the project? Because Purnendu showed a lot of KPIs and other things coming out at the end. But when you start a project, how you convince the management or the people who are investing to actually deploy, and how do you show it? So it's more of that kind of a question that I wanted to ask.
Yeah, it's a the very good question. Even being in the academics field, this this is a concern to us. So, but the first thing we have not, though it has, the question came up in our mind, but we are not trying to address fully right at this moment. The more challenge is that these technologies, whatever the the industry 4.0 methodologies or the technologies, even though we are unable to deploy them the properly. So first thing is that we have to see that these technologies are good and bringing fruits to the industries. At least it can solve the industrial problems, technically feasible, and it can yield the thing which we want. And after that, gradually we have to think that whether it is capital intensive, whether it will be financially justified or not. But what I would suggest is that what I would like to mention, one of such examples for the MSME applications. I've also shown that in the PPT, while analyzing the product quality, instead of capturing the image by using a very costly camera, we thought that if it is to be applied at all adopted by the MSMEs, then the infrastructure cost should be very low. So we adopted just made use of the webcam and captured that the image, knowing the fact that the webcam quality would be inferior to the quality, the high quality camera. Then we thought that how AI what would be the potential of how AI can be implemented into this, so that we can come up after the image augmentation quality enhancement, whether it's at par with the quality of the image that is taken by the costly camera. But this is one example. It's a very small example. But it may happen that there will be some cases in the industry where you have to use this costly the infrastructure. So the question is not. I can't give you the complete answer. But in my understanding, from the academics perspective, the implementation of this theory is really a challenge for the proper the justification of the industry 4.0. So that we are working on, but gradually we have to think. Then only the industry, mostly the MSMEs, can adopt, even though there is a government's mandate of implementing industry 4.0.
Thank you, sir. So
thank you, Professor Pal.
I just wanted to get a view from Purnendu and Pratik also. Just maybe a very short view on this. Yes.
Yeah, Dr. Pal. So very valid question. And what happens is that when you do the initial value assessment, right? When you are trying to set up a digital strategy roadmap. So at that point of time, the entire system cost will be incorporated in the value assessment exercise. And the objective is that I want to minimize the downtime of my machine. So that downtime of say 1 hour would actually be related to business in terms of what is the productivity loss, what is the other aspect of business, right? So there is a dollar value, rupees value attached to that. And that has to be lot more higher, multiple X times what you would have invested in your hardware, including IoT sensors, as well as in the software or IoT platform stacks. So the, say for example, TCS, when they go for these projects, they also have a value assessment module which they carry out. And some companies have their own, like, because they like to see the cost invested and what is the return which the KPIs once solved will yield to. So that is the general approach.
Thanks. Prateep? Just
Yeah,
before we
so
close, maybe 30
absolutely. I mean,
seconds.
yeah, I'll just completely what Purnendu said. And on that, one thing is, for example, our company for some engagements is also offering a, outcome-based pricing. So we only charge our customers based on when the whole thing becomes, I won't say profitable, but it achieves its return on investment. So that's one. There are two more things I think which are important in this context. One is many of these projects are triggered by the fact that customers are increasingly beginning to realize the importance of data and what data can give through either using techniques like AI or machine learning, etc. So that in turn is driving many IoT projects because you have the potential of using data for something good. You therefore need IoT, and therefore the IoT investment becomes justifiable because that use of that data will give the return. So that's, I think, the second reason why these projects are being justified. And the third is, of course, regulatory requirements. There are many things where IoT is helping in security and regulatory things, and I think these are investments that you cannot say no to these days. So you have to do them anyway.
Thanks, Prateek. I think we're done. So Tanusham, I think we're short, but
Yeah, I have just one
Yeah.
just last question to Professor Dr. Arpan Pal. That is, now in academics, students are all talking about IoT needs security, right?
Yeah.
So blockchain is the only solution. So blockchain and IoT, are you mixing it together to provide the solution? What is actually happening in industry?
Yes and no. So point is, again, you cannot just force fit this thing. So blockchain has a much more, I would call, a practical application in the financial segment. In IoT, you can use it, but again, wherever it is needed, people are actually using it now. But it's not that everywhere where blockchain is needed. So when you are just transmitting small packets, small this thing, all depends on the transaction and value of the data. And depending on that, it will be taken care of. So I think it is a little detailed here. So I think that's my short answer. So it is being used, but it is not that it is the only thing. There are many other standard security things also can be used in IoT.
Thank you. Thank you very much.
Depends on the application. Yeah, Tanusha.
Thanks all panelists, Dr. Arpan Pal, Dr. Purnendu Sinha, and Professor S.K. Pal, and also thanks Mr. Prateep Mishra. Now it is over to Devashish. This session of industry session is now over. So it's over to Devashish. Now please follow with the next proceedings.
Thank you, Dhanusham.
Thank you very much.
Conducted an excellent
Bye-bye.
session along with all the experts from TCS, and we are really glad you have given your valuable time, and wishing you all happy Holi. Thank you, sir. Thank you very much. Thank you.
Thank you.
Thank
Happy
you.
Holi. Bye-bye.
Bye. Bye.
Bye, everyone.
Bye.
Thank you. Bye-bye.
Please
Thanks,
note that
I'm
those who are in the technical session 9, please stay in the session. All those authors, check the chat box of Zoom. Those who are for the technical session 10, please check the chat box. We have provided you the link. Please go to the link if you have not already joined.
Thank you.
দেবাশিস খুব ভালো হচ্ছে, থ্যাংক ইউ ভেরি মাচ।
থ্যাংক ইউ
খুব
স্যার।
ভালো লাগ খুব ভালো লাগছে, খুব এনজয় করছি আজকে ছুটির দিন, খুব এনজয় করছি। ভেরি নাইস, your selection is excellent, speakers are very excellent, excellent.
All credit goes to Tanusham. Tanusham is here present.
Then subsequently, it's your
তনুশ্যাম
credit
খুব ভালো
always.
কাজ করেছো, ভেরি নাইস।
Thanks Devashish for giving me the opportunity. You made me the, industry chair there, so I could get the opportunity to do
আর
this.
তনুশ্যাম খুব সুন্দর কোঅর্ডিনেট করলে সেশনটা। বাহ,
Shubha,
ভালো হয়েছে।
thanks.
ভালো হয়েছে, ভালো হয়েছে। আমরা এটা কন্টিনিউ করবো এরকম ধরনের, একদম ফার্স্ট ক্লাস।
হ্যাঁ, পার্টিকুলারলি সেশনটা যেটা ছিল, যেটা দেবাশিসকে বলছিলাম, যেটা যে প্রফেসর ইস্তেফাল আইআইটির মানে ইন্ডাস্ট্রি, একাডেমিয়া, রিসার্চ এবং ইমপ্লিমেন্টেশন সবগুলো একসঙ্গে তিনটে একসঙ্গে দিয়ে পাওয়া যায়, তিনটে ভিউ একসঙ্গে পেলে ভালো হয় সেটা সবারই পক্ষে।
ঠিক 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 ঠিক। অ্যাপ্লিকেশন অ্যাসপেক্ট গুলো তো এক্সেলেন্ট হচ্ছে, দারুণ, কত নতুন জিনিস জানা হচ্ছে, আশ্চর্য।
সুব্রত দা,
আরে কেমন আছেন স্যার?
আর কিছুক্ষণ থাকুন এই সেশনে, অনেক নতুন জিনিস জানতে পারবেন।
হ্যাঁ,
আরে আছি, তোমার সেশন তো এটা থাকছে, এটা আমি অনিরুদ্ধ, তোমারই তো সেশন এটা, এবার তো বোধহয় এটা ওই মানে লাস্ট সেশন বোধহয় এটাই,
একদম লাস্ট সেশন। এখানে ভয়ঙ্কর কিছু থিওরি আছে, দেবাশিস মুচকি হাসছে, কিন্তু দেবাশিস সব বুঝতে পারছে।
আচ্ছা ঠিক আছে, চলো শুরু করো। খেলা, ইন্ডিয়ার ব্যাটিং শেষ হয়ে এসছে, ওদের ব্যাটিংটা দেখতে হবে এবারে। ফার্স্ট হাফে ইন্ডিয়া ব্যাটিং দেখতে পেলাম না আজকে আর সেশনটার জন্য।
ব্যাটিং শেষ, অল আউট
হয়ে গেছে। আচ্ছা, আমি দেখতে পাইনি খেলা আজকে।
লাস্ট 4টে উইকেট পড়লো 8 রানে, লাস্ট